Yeah, yes, please.
Now, see, at lunchtime, I'll put it on the line.
Okay.
Actually, I accidentally overwrote my talk.
Oh,
So I'm trying to update it back to where it was before I overwrote it. So
sorry.
there's an iCloud issue. Beware of iCloud.
So you'll be doing the presentation, the PPT using Mac.
Yeah.
I guess there's no issue, but if you can, by lunchtime, come here and we'll have to test if it works.
Yeah. Okay.
Just because it's Mac, I'm sorry.
Yeah, sometimes the video doesn't work.
Okay, good.
But it's slow tech.
Okay, good. Thank you so much. Buongiorno, professore.
Ma io ho solo 3-4 slide.
Sì, 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 ma per convenienza le sistemo
Sì,
tutte
sì.
su questo computer.
Academy
Torino.
Torino, sì.
Ok. E io... Ok, questo è safe.
Posso vedere se funziona?
Ah, certo,
Sì.
a lei.
Funziona benissimo. Vediamo un po'.
Oh,
Il
oh.
mouse.
Ah, non c'è,
no, no, ma non
o c'è il
importa.
touchpad o
No, no, ma io
la
sono
tastiera.
abituato.
Perfetto.
Benissimo, ok.
E se mai volesse c'è anche il puntatore laser,
Sì, sì.
nel caso.
Non è che devo presentare, devo solo presentare i saluti dell'Accademia di Torino.
Grazie infinite. Tu riesci a controllare che cosa si chiude?
piacere. Lui è
Antonietti Nicolò, piacere.
Non volevo disturbare, quando facciamo la presentazione abbiamo lo schermo di fronte.
Sì, sì,
Se ha
sì,
una
sì,
presentazione-
ed è lo stesso.
Sì, no, perché sennò diventava complicato.
Per caso lei mi... Ah sì, lei mi ha già inviato la presentazione. Ok, perfetto.
Doveverla mandare.
Grazie.
No, ma il computer? Il microfono del computer.
Il microfono del computer, beh, è già
Ah,
attivo, no?
sì, sì, sì.
Quindi sta
Alza il
sentendo.
volume magari se si può del microfono.
Beh, no, beh, c'è su...
Beh, no, non... nelle impostazioni audio, no?
C'è
Quando lo
su...
fai su Zoom non c'è problema, ma io dico proprio se puoi impostarlo... Vedi, se si può. Niente, allora mi dite grazie.
Attivo, non c'è un volume per il microfono.
Avete sempre su Zoom
Su Zoom sì.
come impostazioni?
Di là, c'è il simbolino giallo con i canoni neri.
Oppure in
Microfono.
questa cosina qui, questo apice, esatto. Gruppo microfoni.
È solo per gli speaker il wifi.
Impostazioni audio.
Ok. Microfono.
Altoparlante,
Livello
microfono.
ingresso, come metterò al massimo?
No,
No?
non me lo fa muovere. È probabilmente gestito da qui.
Perché lui adesso ha questo. Prova ad abbassare la tendina. Qua ci sono più microfoni.
Però devo usare questo perché altrimenti non va.
Il microfono lo gestiscono loro il volume, mi sa.
Ah, ok.
Non lo fa.
Non si riesce a modificare.
Dove un po' di distribution è un po' lì. No,
Sì.
facciamo sedere sul palco i primi magari. Quando stai per iniziare, quando stai iniziando magari ti chiami i primi dicendo se vogliono già iniziare a sedersi.
Si perde tempo.
finalmente.
Funziona lo scalino
Sì,
ancora.
infatti che
Sì, c'è mezza rampa e mezzo
ho
scalino, la
tolto il
cosa
gesso
peggiore.
lunedì.
Ma dai.
Mi sono rotto un po', insomma, porca miseria.
Mi spiace.
Ma roba casalinga o al lavoro?
No, no, attraversando la strada davanti a casa.
Ah, cazzo,
Perché tutti
allora.
mi chiedono, sciando?
Sì, sì.
Magari.
No, infatti non avevo più.
Cioè,
Bello. Messa in
Grazie.
piedi. Che sono rimasti carini, vero?
Sì.
Un sacco di gente.
Ah, lei è scritto a mano.
no, ma
perché
proprio
io
a
ho
lei non
saputo-
gliel'hai fatto fare.
Ho saputo che venivi ieri. Ormai erano già andati in
Infatti,
stampa.
io lo davo per scontato che diceva Alessandro, ma qualcuno ha detto che...
E se non me lo diceva lui, io non...
Ma noi gliel'abbiamo anche detto, poi di a Erika di venire,
sì, ma
falle il
assolutamente.
badge,
non
però
sono stato a
non
dire,
la
sinceramente,
svolta.
perché ho
Una delle
detto-
prime cose, credo che...
Era... No, non volevo rompere le palle, onestamente, però vabbè.
Dai,
Boh,
via,
quindi
passiamo.
manca il primo...
È in
quello
inglese,
che-
giusto?
Tutto in inglese, sì.
Aspettiamo ancora perché
Aspettiamo un po'.
La Cirio? per
non
fine
contando
fa-
Ma hanno
pagine.
mandato il video.
Ah, mandato il video.
Sì, sì, perché a Firenze oggi non
Ok.
potevo.
Adesso siamo in piena campagna elettorale.
Sì, ma avranno, io penso, una riunione tra tutti i presidenti di regione, credo che fosse una roba simile.
Sì, perché poi loro dovranno andare via, però loro hanno detto che possono stare pochissimo, non andare troppo lunghi con l'inizio del...
Però è sicuro, non è che adesso proprio... Questi li piglio io, va?
subito,
I liberatori li prendo io, tanto servono a me formalmente
Serve a
come
firmare.
associazione. Ci vediamo, tu rimani...
Comunque ho spento il microfono lì per dire che era acceso.
Andate in mondo visione.
Ciao caro. Ma sì, che sto abbastanza bene rispetto a prima, rose e fiori. Ma duale perché sono un pezzo grosso. Beh, è quasi così, è quasi così. Sì, lo sai, tu ricordi alla conferenza di Civitarca, sua madre, scusa, suo marito è mancato qualche giorno fa. Ti mando poi un'email, comunque era Jack Welch, ma era anziano. Sa ragazzi, perché adesso qui bisogna cominciare. Va bene. E chiama quella signora che sa dell'incidente. Bravo. E quando sarebbe? Dall'ala, certo. Vengo poi a vederla, dimmi dove è. Allo IAC, no, d'accordo, ma lo IAC è grande. No, io ci sono di sicuro. Mi dai poi l'indirizzo, io vengo poi. Sì, certo. D'accordo. Bellissimo. D'accordo. Dai, chiamami. Quando volete cominciamo,
Sì, cominciamo.
Parli tu, dai.
Sì, così. Good morning. It is my very pleasure to start this first International Academy of Astronautics Symposium on moon Farside protection that is being held in Turin, which is one of the main aerospace cities in Italy. And it could not be done without the idea of this gentleman next to me, Professor Claudio Maccone, who is the chair of the IAA Moon Farside Protection Committee, and he's been involved with the moon Farside protection since years, and it has finally come to this symposium. I want to thank you all the patronages and sponsorships, and we can start with the speakers. And the very first is a video recorded by the president of the Piemonte region, Alberto Cirio, who could not make here, but he left us with a video.
Ringrazio davvero gli organizzatori di questo importante convegno internazionale che ci proietta sulla Luna, che ci fa parlare di aerospazio e che soprattutto certifica ancora una volta come Torino e il Piemonte siano la culla dell'ingegneria aerospaziale. È infatti un motivo per noi di grande orgoglio, ma anche di grande rilievo economico, il fatto che l'industria aerospaziale italiana veda nel nostro Piemonte, nella nostra Torino, in questo territorio straordinario fatto di ingegno, di capacità e di studio, un luogo in cui organizzare e mettere le radici per quell'industria aerospaziale che sta dando tante soddisfazioni in termini di ricerca, in termini di risultati raggiunti, ma anche in termini economici e occupazionali. Pensate che soltanto nel nostro Piemonte negli ultimi 2 anni gli addetti al settore dell'industria aerospaziale sono passati da 20.000 a 38.000, quasi un raddoppio esponenziale, e questa è anche la forza non soltanto della nostra industria, ma anche delle nostre scuole, del Politecnico, dell'università, perché davvero qui si riesce a trovare un'unione molto forte tra la capacità di saper fare, ma anche quella di saper studiare, insegnare e approfondire. L'industria aerospaziale è sicuramente uno degli strumenti con cui noi possiamo guardare al futuro con la consapevolezza di quanto è importante l'industria della difesa, di quanto è importante parlare di spazio, di quanto nello spazio e nell'aerospazio potremo trovare magari soddisfazione anche a problemi che oggi il nostro pianeta sta vivendo. E per tutto questo il Piemonte è pronto a continuare a fare la sua parte, così come ha sempre fatto, lavorando fianco a fianco delle imprese e delle aziende, mettendo a frutto i fondi europei dello Fondo dello Sviluppo Regionale e soprattutto mettendo la prima pietra per la città dell'aerospazio che prenderà vita tra breve qua a Torino e che vede la nostra regione tra i suoi principali sostenitori. Buon convegno e buona permanenza in Piemonte a tutti.
Thank you to Regione Piemonte. Our first presenter is, in person, is Dr. Mario Cosmo. Is in, no, okay. Okay, so he's not here yet. So let's skip to the next presenter, Professor Erasmo Carrera, AIDA President, for the AIDA Welcome Address and IAC 2024 presentation.
So, good morning, everyone. So, I'm pleased to be here and to give the appreciation of the Italian Association of Aeronautics and Astronautics for this event, and thank you to Dr. Maccone for organizing this wonderful meeting. I don't know why he's going ahead. Okay. And of course, also, I think Jean-Michel Contant is not yet here, also the International Academy of Astronautics for making this possible here in Torino. So, but I'm here to talk about the AIC in Milano. So the AIDA, as you see here, is the host of the next International Astronautical Conference that is going to be held in Milano in October this year. As you may know, this is the largest event in astronautic worldwide, and you will see the number we are recording for the edition in Milano, which is the 75th. And this, by the way, is 60 years later, the first Italian satellite, San Marco. So we will take this chance to celebrate Professor Broglio and the San Marco mission as well. So we have we are organizing this event in Milano not only as AIDA, which is the Italian Association of Aeronautics and Astronautics, but is really an event organized by the entire Italian community. We have a co-host, the Italian Space Agency. I've seen that Dr. Cosmo is going to join from ASI, and Leonardo as well. So it's really an Italian team organizing the event. But of course, the IAC is not the unique event we will hold in Milano. We will have also some other events. The most important one are the yearly meeting of the Academy of Astronautics. It's going to be there on Saturday and Sunday before the AIC, and then we will have also the event of SGAC. I see also some representative Antonino here today. So we are always in the same place, passionate of space. So let's give you an overview of what we want to offer you in Milano. I'm sure that many of you will be there, and you will continue to discuss about this extremely interesting topic of this meeting today. And we hope also to apply our motto to this Farside part of Moon, that is to make everything sustainable. So this is part of our duty during this day. So you see some numbers here. Date, the city of Milano, we will make it in MICO Center. MICO is Milano Convention Center, is one of the largest convention center in the city, not only in Italy, but in Europe. And you will see some data for that. So let's give you some numbers and some information about. So for the first time, we have more than 7,000 abstracts. So in Paris, which was a record 2 years ago, we got 4,500 abstracts. So this is really a huge number. This has never been done in the past. So someone say that will never be done in the future as well. So we do expect 10,000 delegates. And we have also doubled the exposition area. And usually when you do this, you have spaces until the very last day. But I have to say we have sold out all the square meters we have until now. So we are trying to make some additional space in Miko to accommodate the request we are getting. And so we have many sponsors, the traditional ones, and we are getting new ones also for this event in Milano. So you see, so the numbers are really impressive. And CEO are very proud to do that, that you know, we are somehow actors of this event. So we see the number is 45% more than the best in the past. So, and what is extremely important for the AIDA, because we are the Italian Association of Aeronautics and Astronautics, that for the first time, Italy is going to be the first country in terms of contribution, scientific contribution to the IAC, and Italy has almost proposed 1,000 abstracts. So in the past, Italy had the 5th to the 6th place. This time will be the first country. So in Italy, we will have, say, 1,000 people passionate of space presenting their own findings in Milano. And this is really something unique. It's 1/7 of the abstract. We will see, because next week we will have the selection of the abstracts. Difficult to accommodate all the proposed one, but I know that the Federation is doing its best with help of many people to accommodate as much as possible abstracts. So, as I say, also the exhibition is really huge. So, once again, we have also some collateral events. The Space Generation Congress will be for the first time in the same place of the AIC, in Miko. And we have also some political events, so some ministers will be there related to space activity. This is MMOP. And we have also our ONU workshop at Miko, and of course the IAA Congress and the International Institute of Space Law Moot Court as well. So it's really very huge event. We have a program. I don't have a slide about the program. The program of the AIC is extremely complex. You have so many parallel things. We will have an open day on Friday and so many activities of outreach and for passionate, not extremely, into the topic. We will have also about 20, 25 astronauts working at AIC Milano in that week. And of course, Milano is also a place for doing also some other interesting things, also in the area of Milano. For visit tourism, and we are also organizing some technical tours. Now we have got some offers from the area of Milano and Veneto. Some others from the Piemonte will come soon, so people can book tours in some special companies. And I want also to close that this year for the AIDA, the Italian Association of Aeronautics and Astronautics, is really a very special year. For us, is Aerospace Italy 2024, because as you see in this slide, in the logo, so you have the Colosseum, the Dome, the Milano Dome, the Milano Cathedrals, and Palazzo Vecchio in Florence, because we are having in Italy the three most important events in aerospace in the same country in the same year, organized by the same association. This has never happened in the past. So we will have IAC in October, ICAS, which is the one on aeronautical sciences in Florence, and then we will have the aeroacoustic conference in Rome, and the numbers are, we do expect 700-800 in the aeroacoustic conference in Rome, which is also a record, never done this. The ICAS in Florence, we came up 1,000. This was never happened in the past, and then AIC is 10,000. Okay, so it's completely different numbers. So I hope to see most of you at AIC and have a good conference. I'm sure you will get a very good conclusion and probably suggestions to protect the moon, the Farside part of the moon. So thank you very much.
Thank you, Professor Carrera. Okay, Dr. Dario Peirone could make it here. So our next presenter is Dr. Dario Peirone from the CEI Piemonte, and the title of his presentation is The Welcome Address by CEI Piemonte.
Thank you very much. I'm also a professor, but coming after Professor Carrera, of course, is always very difficult. But I'm very glad to be here. I think it's a great opportunity for us to present the fantastic cluster that we have here in Piemonte, the wonderful ecosystem about aerospace industry, in particular space industry. We have a fantastic collection of capabilities, and our role as CEI Piemonte is an institutional role to support the small-medium enterprise who are the backbone of this ecosystem in facing the challenges of international market. With the big companies at international level, and we are also helping to attract investment on the territory. Of course, attracting investment on the territory is a big challenge, particularly in Italy, for many reasons. But for us, in Piemonte and aerospace are very attractive. And I must say that it is one of the supply chain where we have been most successful in recent years. We attracted companies and also startups, so innovation on the territory. In the last 2 years, it was quite a bunch of companies arrived in Piemonte from United States, even from Ukraine. So I think it is a very important point to be here, also looking at the big events, the big appointments that Professor Carrera was mentioning. We think that is a great opportunity to have the International Astronautic Conference in Italy. And so we are ready here to collaborate with all the players, with the companies, with the ecosystem, and of course with the very important cluster, the Distretto Aerospaziale, chaired by Professor Quagliotti here, to support our companies and to be present in this important event. Congratulations also for the argument. We think that this argument regarding moon Farside protection is very important and particularly in the right moment, I think, considering that the direction of the market and of the industry. So we are here with our team. In particular, I like to welcome our general manager, Stefano Nigro, and our aerospace manager, Engineer Manis. Probably some of you know them, but I'm sure that you will have occasion to know them. We are here to listen, we are here to help and to support our ecosystem. Thank you very much and have a nice and productive day of work.
Thank you, Professor Perrone, for the welcome from the CEI Piemonte. Our next presenter is Professor Giancarlo Genta, and he is from the Academy of Sciences of Turin, and he's going to give the Academy welcome address and prospects of moon Farside protection.
A few slides.
Sure. The podium is yours.
Well, first thing, good morning to everybody. I am here on behalf of Professor Massimo Mori, who is the president of the Academy of Sciences of Torino. He asked me to give you his best wishes for a good meeting and for a productive meeting. As a first thing, I would like to say 2 words about the Academy of Sciences of Torino. That is one of the oldest Academy of Sciences in Italy. Obviously, it is much younger than the Academy of Lincei that dates back to Galileo, but it has about more than 250 years of history. It was started as a private scientific society of Torino in 1757, and it was founded by 3 persons, a chemist, Count Giuseppe Angelo Saluzzo di Monesiglio, a physicist and physician, Giovanni Francesco Cigna. At that time, science was not as specialized as today, and one could be a good physicist and physician. And above all, Joseph Louis Lagrange, the very well-known mathematician and mechanicist, who was born in Torino in spite of his French name. He was the son of the ambassador of France in Torino. They founded this Academy of Sciences, and the Academy was recognized by the King of Piemonte in 1783. In just 2 years, produced the first publication, which included 2 texts, 2 writings by Lagrange, so very high-level works. The Academy of Sciences of Torino has always had many foreign members, and about its members or scientists who published on the publication of the Academy, we can say list Euler, von Haller, D'Alembert, Marquis de Condorcet, Charles Babbage. Charles Babbage was the person who built or tried to build the first computer, programmable computer, in the middle of 19th century. Obviously, it was a mechanical computer, and Charles Babbage lived many years in Torino and was a very active member of the Academy of Sciences of Torino. Also Faraday and a lot of other very well-known scientists like Maxwell were members or published through the Academy of Sciences of Torino. Here we have the main lecture hall. The main lecture hall is where even today the members of the Academy of Science meet, and was a place where Lagrange made most of his works. We can say that Lagrange didn't work a lot in France. He worked a lot in Torino and then in Berlin. Then he was also in France. And during the French Revolution, he had a lot of troubles in France. Okay, this is the main lecture hall. Here we have the globes. They are very interesting because they are very interesting globes that date back to 1688 one and 1693 the other one, and were donated at the beginning to the Academy of Sciences by their owner, that was a scientist in Torino. By the way, on the roof of the Academy of Sciences in Torino, there was an astronomical observatory and remained active for making observations before it couldn't anymore work because the air over Torino was too much polluted by light, and so the observatory was moved to Pino Torinese. By the way, the initial observation of Schiaparelli were made in Torino. Then Schiaparelli moved to Milan, and he was working at the Academy of Brera in Milan. Here, the last slide I have is the whole of the catalogs of the library of the Academy of Sciences. The Academy of Sciences started since the beginning to collect books, scientific books, but not only, and now it has 300,000 volumes, and this is the whole of the catalogs. Think what was maintaining a catalog with so many books in the pre-computer era. And so they had these big drawers with all the documentation of each book. Okay, this is the Academy of Sciences of Torino. Today is active, very active, and has shifted, as all the academies of sciences of the nations. The Academy of Astronautics is a completely different thing, because the Academy of Astronautics does scientific work still, publishes the cosmic studies and so on. But the Academy of Sciences don't have money for research. General research today is very costly, contrary to the past, and so it is dealing mostly with outreach activities and activities with schools to interest students and young people to STEM subjects, but not only, because the Academy of Sciences of Torino has two classes. One class is for hard sciences, physics, mathematics, chemistry, geology, and so on. And one class is for soft sciences, philosophy, literature, and so on. We note that in Torino we have the biggest Egyptian museum outside Cairo in Egypt. Is even bigger than the Egyptian part of the British Museum in London. And the Egyptian Museum is in the same palace, that is a palace of the 16th century, and is linked in a way with the Academy of Sciences of Torino. So I tell you, good meeting, and the Academy of Sciences was very interesting in this meeting, because you try to give rules for when the moon will be integrated in human community, and when the moon will be a place in which industrial, not only scientific activities will be held. Industrial activity need rules, and this is the basis of our way of working. Just something personal I want to add, and I want to add that rules are needed, but when you establish rules that involve not only scientific but also industrial activities, you must be very careful not to make useless rules. That is, rules must be the strict minimum that allows and encourage economy, not only science, that protects science, as in this case, in which science has to be protected, but they must also influence and improve economical activity. Lunar economy is essential for our civilization, and lunar economy will be very important. So we must, we can say, contemporate the need to protect science and the need to allow industry and economy. So the rules must take into account both aspects. I've cut here, and I bring you again the best wishes to have a productive meeting from our director, Professor Massimo Mori.
Thank you to the Academy of Sciences in Theory, and thank you, Professor Genta. Our next presenter is Professor Fulvia Quagliotti. She's president of Piemonte Aerospace Cluster, and she's going to give the welcome address by the Distretto Aerospaziale Piemonte. Thank you. No,
Good morning. I apologize for my voice today. I would like to thank you for the invitation to this important event. The subject is very challenging, so I think that the discussion will be very, very interesting. Let me spend a couple of words on the history of aerospace here in our area, in Torino and in Piemonte. Well, we start far time ago in 1909 with the first flight of the first aircraft completely built in Italy. And after that, non è una questione di acqua proprio, thank you. After that, the aeronautical activity from scientific and from industrial point of view evolved very, very rapidly. And at that time, obviously, the space was limited to the very low space. But in the middle of the 60s year, Fiat Aviazione decided to look to the space activity in parallel with what was done by Professor Broglio in Rome with the studies that are very, very known. At that time, there was really a small group working in Fiat Aviazione on space in collaboration with the two European organizations that were at that time present, ELDO and ESRO, divided from launchers and satellites. Then they merged in the ESA activity. And after that, we can say this was the origin of the Thales Alenia Space. Just to come what is the activity in Piemonte now on the space. So Thales Alenia Space is a very important company that probably you know very well, and is the leader for the robotic and human space exploration. So we are very proud in the Piemonte Aerospace Cluster to have Alenia Space as one of the associated. Coming to the cluster, our cluster is an association including institutions, You are the president of Piemonte region that mentioned this activity. We have the region, the city of Turin. We have the industrial association. There are two, the Unione Industriali and the Small Industries Association. Then we have the Chamber of Commerce, the academia with the 3 universities that Professor Peirone already mentioned, and we have also research centers and a large number of SMEs. The SMEs are really the scope of the activity of the cluster, because we just are a little bit more than 100 associated in any case. And the scope, the main scope of the cluster is to support the SMEs in parallel to what is doing the group of Professor Peirone and Dr. Nigro in approaching the programs, but we are working on the technological point of view in support and in coordination with the organization of Professor Peirone. So our industries are generally very small. Some of them are coming from automotive, so they need to be experienced in aerospace as well, and they need support also in certification, of course. So they have to be able to create a network to participate to the European programs and to the international one. In collaboration, of course, with the large industries. Well, the large one have the supply chain, but they are in any case open to include in the collaboration the other industries, small industries, of course, and especially to look to the regional experience. Is quite important, because we have in Piemonte a unique situation with respect to the national one. We are the only region where all aerospace activities are present. We have the aircraft, with the exception of helicopters, but we have in any case a large industry that is supporting system for helicopters, so helicopters are partially also here. We have the propulsion system with Avio Aereo and with the supply chain. We have Collins Microtecnica for onboard system and partially for space also. We have Maker, as I mentioned before, for helicopter system, and we have Thales Alenia Space. So it's a unique situation to present a coordinated experience and capability also outside Italy at international level. The large industries are able to be a sort of training system for the SMEs in this way. This is what is occurring now. We are increasing. The president of the region mentioned the number of people that is working in aerospace, but we have also to consider that the revenue was last year 8 billion of euros. So this is really consistent for a region like we are. What I can say more? It's also important the collaboration between university, which is academia, and industries. We are working on this subject on the city of aerospace that is just starting with the first ceremony was November last year, but it consists of 12 projects, separate projects but connected. Therefore, it is an ecosystem for aerospace in a very large area, is 1 million square meters. And we are starting with the first activities with laboratories in collaboration among industries and universities and research centers, but we are going on also on other projects like that one that looks to to host together SMEs in the same area inside and in a very short contact with the large industries that are still there. So we hope that with this very ambitious project, we can grow up as a region on aerospace, but we are looking, I was speaking on aerospace, of course, but we are looking to space because the space has the higher derivative of growings in this time more than the aeronautical side that is going on traditionally, I can say. So I wish you a very, very good meeting with very important new information on the scientific progress on the subject that you have here. Thank you.
Thank you, Professor. Few more welcome speeches were expected, but the people are not here yet. So we can start with the technical presentations. And the first one will be made by Claudio Maccone, Professor Claudio Maccone, who is one of the IAA technical directors. He is the chair of the Moon Farside Protection Permanent Committee of the IAA, and well, the idea for this symposium is his, so thank you for the organization. And he's gonna talk to us about the international challenge of Moon Farside protection. Roughly, technical speakers have from 20 to 30 minutes. When you're about the end of your talk, I will let you know, and, well, expect 5 minutes for questions in case. The podium is yours.
Thank you. Thank you very much, and good morning to all the people that decided to spend 2 days here in Turin, visiting possibly a town that is not very well known outside Italy and the aerospace world. So before going over to technical matters, please let me thank my co-workers. First of all, Niccolò Antonietti, please stand up. Thank you. Second, Luca De Rosa, please stand up. Thank you. Third, Christian Firrone, please. And there is a fourth person. He is not here, he is in Paris at the International Academy of Astronautics, and his name in French is Monsieur Fabrice Dalmont, who is actually the right-hand side of the General Secretary of the IAA, Dr. Jean-Michel Contant, and he is always the first person that I contact by phone in order to decide anything about future possibilities, activities of the International Academy of Astronautics and so on. So I thank these four people. Thank very much for your support. Okay, now let me just start very quickly about history. I thank already Professor Genta for describing the role of the Turin Academy of Sciences. And so, in particular, I would like to mention two people that were mentioned already. I'm using the German pronunciation, Leonhard Euler, who was the famous mathematician of the middle of the 18th century. And around 1760 or so, he discovered the first exact solution to the three-body problem, which was a really complicated mathematical problem for that time. Of course, he did not have any idea about the space application, as did Lagrange. I mean, they were just excellent mathematicians, And so they did it for the pleasure of doing calculation, so as to say. But actually, they opened new way to space mission that we are using today, even if in an approximated way, of course, because the real thing is not exact. You have to approximate numerically all the problems. So after having mentioned this to people, let me say that, as Gent had already mentioned, Lagrange was born in Turin on 25th of January 1736. And the name is French, of course. Many people in the world maybe think he was French, but actually he was born here. I have to be frank, however, please. At that time, that is in the 1700s, this part of Italy was somehow mixed in between French and Italian people. And even in later times, the dialect that we used to speak in this part of Italy is 50-50 in between French and Italian. Anyway, here you see the house where Lagrange was born. It is located at number 29 Via Lagrange. So if you want to see it, you just catch a taxi cab and you ask, please take me to number 29 Via Lagrange. And you see, I am moving the cursor here, this inscription here mentioned the fact that Lagrange was born in this house, as I said, on 25th January 1736. Let me make a confession. In the past, I have tried to establish a Lagrange museum in this building. Unfortunately, politics beated me, and I was not able to create it because the building had been fractionated just a little before. So it was just a little bit late. Nevertheless, the dream is still alive. So for the future generation, if we can, we would try to build up a Lagrange museum in Turin. Okay, now let's go over to a bit of mathematics, please. I'm not using the equations, of course, but this diagram shows the 5 Earth-Moon Lagrangian points. You see, here is the Earth, of course. This is the Moon that revolves around the Earth, in reality on an elliptical orbit, but it is very, very close to a circle. And so the idea was that Euler discovered the 3 Lagrangian points, L1, L2 on the other side of the Moon, and L3 on the other side with respect to the orbit of the Moon around the Earth. And then Lagrange complemented this discovery by discovering 2 more points, the triangular points, L4 and L5. Of course, these 2 triangles are equilateral, meaning that each angle is 60 degrees. And of course, the whole system revolves when the Moon goes around the Earth, okay? Now, this is the Earth-Moon system, but in reality, if you go outside the sphere of gravitational attraction of the Earth, you have 5 more Lagrangian points in the Sun-Earth system. So this is the Sun, this is the Earth, very small, not to scale, of course. Around the Earth is the Moon. And there are 5 more Lagrangian points of the Sun-Earth gravitational system. They are very important for space missions. For instance, the Lagrangian point L2 above the far side of the Moon has been used already in several space missions because actually the light of the Sun is shielded by the Earth in between, and so it is a very good position to do scientific research. Also, it's not gravitationally stable, but with little correction, hydrazine and all that, we can make it pretty much stable. Let me tell you that, especially in the French literature, the orbit going from the Earth here to a Moon flyby or swing by, which is the same, to going around the Lagrangian point L2 of the Earth, Sun-Earth system. This orbit in the French literature is called the Lissajous orbit. Actually, this gentleman was Lissajous. What he really discovered was the double pendulum, but by extension, we call the orbits Lissajous orbits. Now, this is extremely important because, as we'll see today and also tomorrow better in a more detailed presentation, China was the first country in history to be able to set up a relay satellite Shechao, I apologize if my Chinese is not correct, around the L2 point. And this is basic because you cannot keep in touch with the far side of the moon unless you have a relay satellite assuring you the telecommunication from China to L2, to the relay satellite, and from L2 to the far side of the moon. So even in its own, this was an achievement by China, and that was in 2017. Now, I am making now a jump of about 200 years or more. Sorry for putting this, but I have to be clear. This is my badge at the United Nations COPUOS, Committee on the Peaceful Uses of Outer Space. I was there with some colleagues that are here today. And as you see the dates, I was there just about a month ago. And what was that? Well, here is a picture of one of the main rooms, actually probably the main room. You see, it's a sort of parliament with seats for all countries. You see Venezuela seats and so on, that are hosting non-governmental organizations, NGOs, at the United Nations level. And this is the building of the United Nations in Vienna, outside on the part of Vienna, the modern part of Vienna, on the left bank of the Danube, okay? So this is where you have to go if you want to talk to the highest political organization in the world devoted to space and space mission, just to try to see something about the future. So I went there, and what I proposed is something very ambitious. I apologize to you if the vision is too ambitious, but I think the time is getting pretty ripe for that. The idea is to propose for the future, of course, not for immediate future, but the idea is to propose a United Nations treaty. Why is that? Well, you will listen to other presentations in this conference because the Outer Space Treaty that was signed in 1967 by the United States, the Soviet Union, and the United Kingdom is somehow backward by today's standards. You know, there are many, many more stakeholders. In particular, I refer to the American private companies. So it is important that some kind of guidances are established at the highest possible international level. And in my opinion, the highest possible international level is the United Nations, that is COPUOS. Now, let me mention very, very briefly the shielded zone of the moon far side, abbreviated SZ or SZ, according to whether you like the American or the British pronunciation. Anyway, let me first of all mention what is ITU. ITU is the International Telecommunication Union, which is today the United Nations branch for telecommunications. It is based in Geneva, Switzerland, pretty close from here. And as early as 1974, the first ideas about protecting the radio quiet far side were actually put forward by ITU, the International Telecommunication Union. And here is what they said. So please look at this diagram. Here is the Earth. Here is the moon. Now consider a telecommunication satellite in orbit around the Earth, which is 100,000 kilometers high. So we need numbers. It's not just talk in plenty words. We need a number. And the number that the ITU fixed at that time, 1974, is a circular orbit around the Earth, 100,000 kilometers high, okay? Now, suppose you have a telecommunication satellite in this orbit. What happens? It happens that the satellite emits radio waves, of course, in all directions, in general. So consider the cone, C-O-N-E, cone, that has the basis on that orbit that I mentioned, and this is tangent to the surface of the moon, and finally reaches the apex or vertex on the other side. Now, I would like to mention two facts. First of all, this part of the moon is really, no, sorry. Yeah, this part is the ITU shielded zone of the moon. So practically speaking, it is nearly, not exactly, but nearly the whole of the Farside, which is, let me use a political term, asking for a lot of protection. You know, if you agree with this definition, then you're practically asking for the whole of the Farside to be protected, legally, of course. And I also would like to mention very quickly the quiet cone that is on the above the far side of the moon. So it's a region of space such that if you put a satellite into orbit around that, and this is article ITU radio regulation article S22, if you put a satellite around the moon, when it crosses the quiet cone, it is of course covered from noise coming from Earth. So it can be used to do scientific research about the universe without noise. But the point is that according to the orbit that you choose around the moon, it may not be long-lasting, okay? So the integration time in technical terms may be small because of the orbit. Okay. Now, sorry if I mention myself. On June 10th, 2010, I went to the United Nations, COP and I made this presentation. What did I ask for? Well, I was aware, of course, of the Farside regulation that is just mentioned by ITU. But I don't know, this is my idea, you may disagree. No problem for me to correct my presentation made at the time. But anyway, my impression was that the more you ask for, the less you get, right? Now, in order to avoid conflicts on this point, I asked for a much smaller part of the far side to be legally protected. Now, please consider two parallels. This is the far side of the moon, okay? Consider two parallels, plus 30 degrees and minus 30 degrees. And the circle in between, tangent to these two parallels. Well, what I asked for at the United Nations in 2010, that is before China reached the far side of the moon, was to protect this circle, and I had to give it a name because apparently no one else had done so before, and I call it PAC, Protected Antipode Circle, obviously because the center of this protected part is practically the antipode point of the Earth on the other side of the moon, okay? Now, why did I suppose that? Because if you look at the same story but from above the moon, you see that this is the circle is the moon. In this direction you have the Earth, and as I mentioned, because of the two Lagrangian points L4 and L5 that are in these two directions, this angle here is 60 degrees, this angle here is 60 degrees. And since already in America, they have made the calculation to set up space stations, especially at the Lagrangian point L5. In America, there is an L5 society created by Bill O'Neill just for this purpose in the 70s or 80s of the last centuries. And so the point is that these 2 points, but especially L5, are gravitationally stable, which is not the case for the 3 collinear points discovered by Euler. In other words, if you put a space station, for instance, at L5, it will keep staying there. It will not move around and leave that position. So, if you consider this, and if you look at the future, 1 century, 2 centuries, whatever you like, then you find that the radiation emitted by these 2 points, emitted by the space station in these 2 points, will hit the surface of the moon, but inclined so that there is a sort of a part of the moon that I call the pristine part. The name is not mine. It goes back to Jean Hedman, a French radio astronomer from Meudon in Paris. This is the slice of the Farside, included between 150 east and 150 west in longitude. So, at the center of this is Daedalus crater that in my presentation in 2010 was selected intentionally to host the first radio telescopes. I just came to learn this morning from other people in the conference that it is a good place, but it is too small. This crater is about 80 kilometers in diameter, but I was told that this is not enough. They want bigger crater. And for instance, Mare Moscoviense, who is on the Farside, but it was discovered by the Soviets during the first Soviet missions, that would be better than Daedalus crater. Now, of course, there is another question, just to mention it very quickly. The question is called diffraction. For people who like physics, the signals that are coming from Earth are not completely shielded by the moon's spherical body. They shift around in a small amount, of course. Small means 80 dBs lower than usual, so it's really small. But nevertheless, it is not zero, okay? So this also has to be decided. And at least in this conference, I came to learn new facts, and you know, we try to take this into account for a possible future treaty whenever it will be available. Now, let's go over to politics, because this is not just a discussion about science. It is, for good and bad, a discussion about politics, space politics, for instance. So the evolving space competition is that is started in 2018 by China, because China landed the Chang'e 4 space mission on the far side of the moon. And then, of course, the USA are planning to do the same. Russia tried, Japan, India, Europe, and possibly more countries, okay? So I would say that, practically speaking, all the spacefaring countries are now rushing to put a foot on the moon. Let me put it this way. Of course, it's very generic, but... Now, the Chang'e 4 Chinese mission was launched in December 2018 and aims at water also near the South Pole, but now that there are more missions that went close to the South Pole, and I will mention this not today, but tomorrow in my second presentation. Anyway, this problem is really important, and the blue area in this picture is the so-called South Pole Aitken Basin, which is essentially a depression with respect to the mean surface of the moon, lying at least in part on the far side. Now, politics and the PAC, the Protected Anti-Port Circle creation. The Outer Space Treaties was signed in 1967. No country can colonize the moon. Planets, asteroids for that country only. Back in 1967, however, it was hard to envisage a time when private investors, this is an important word, private investors could reach the moon by their own means. So really, this is what is happening already nowadays. And at that time, and now, no one knows what will happen when some of the private investors land on the moon. This is my personal opinion, and I hope I am wrong. Anyway, the point is that what the private investors say, not as plainly as this, so I'm pushing the matters a bit forward, but the message, hidden message, but substantial, we have money and pollute as we please. This is not what they say, but this is the danger that we, I hope in this meeting, will have to face sooner or later. Will private investors stay away from the Protected Anti-Port Circle? Almost certainly not. It is as urgent to reach some kind of international agreement. We only have a small window of time. We cannot wait for centuries because if we wait for centuries, they will get everything they want. So let me give you the good news. The good news is that much silence still is there. The Qixiao frequencies are not many. I'm grateful that, to the Chinese people that made clear to everyone what the frequencies are, so thank you very much. If China wants, a radio telescope inside Daedalus or any other crater would still be of great benefit to radio astronomy, which is what astronomers, or radio astronomers as I am, need desperately before the window gets closed. But again, negotiations are urgent among scientists and space politicians. And after this, I thank you very much for your attention.
Thank you, Claudio. Is there any question? Sure.
Yes, Claudio, thank you for this highlight. You mentioned the possibility to have a private companies or commercial companies landing on the moon. And we know now that NASA established a commercial payload program to finance most of those activities and landings. So have you ever had the chance to speak directly with NASA to understand if they are aware about this request? Thank you very much.
Thank you very much. Well, this is precisely one of the two more talks that I will give tomorrow. So the Artemis Accords that were laid recently by NASA, and 36 countries that already accepted this accord. Italy is one of those. And this is a good start, in my opinion, towards a sort of international, quotes, new treaty, space treaty, call it as you please. But this is the first step, because NASA, in many regards, is still the leading space agency about that. Tomorrow I will speak about that. Thank you. My goodness. Nicola. No, many people raised
Claudio.
Yes.
Thank you. Thank you very much for your presentation and for organizing this Congress. I think it's wonderful to be here for these very timely discussions, as you said. I'm a space lawyer. I'm the director of a small nonprofit called Lunar Policy Platform. Tomorrow we're going to talk about policy solutions for ensuring sustainability on the moon. The question that I had for you is, as you already mentioned, the idea of a treaty is very ambitious, and you know that COPUOS, you've been there in February, it struggled a lot to even agree on a title for discussion on dark and quiet skies, just to give an example, and we have Richard Green from IAU here that can talk about it more. So what would you consider as, let's say, a good less than a treaty as we go through there? So it will take, in any event, even if we build the political capital for it, it will take many, many years to get a treaty. What do we do in the meantime? What do you consider acceptable that we can achieve more concretely from, for example, the policy perspective?
Thank you very much, Antonino. Well, my answer is very easy. The Artemis Accords are the first step along this way. First of all, because of the prestige of NASA. Secondly, because, as I will mention more tomorrow about that, 36 countries, basically, of course, Western countries, or if you prefer, all of the spacefaring countries except, of course, China and Russia, all of these countries signed the Artemis Accord. So tomorrow I will give you a more precise answer, but in my opinion, this is the first good step towards a new space treaty.
Sorry, we have to cut for now the questions as the Italian Space Agency research director is connecting. Maybe we can give some more time for questions later, or you can catch up during the break. Sorry, just. Okay. Okay, you're not the only woman, but yeah. Okay, let's give the microphone to the lady.
I have two very short questions, and I will speak as fast as I can. One is about the ITU, the specialized agencies of the United Nations, where frequencies are so few are available now because you know there's an awful lot of noise in the ether. But that, I don't know how they can allocate any more frequencies. But my other question is more important. It sort of proves, because I'm also a space lawyer, I'm a lawyer, several times over, a doctorate in law, is that all my colleagues say that only states and international governmental organizations have rights and duties under international law. I have published 17 books, and number 17 is called Philosophy of the Law of Nations, where I say the most important ones are the individuals and the companies and whatever, and it seems to prove how can you have an international agreement if you exclude the private investors and the private companies?
Thank you. Well, tomorrow I will be giving 2 speeches, and the third and last speech of mine is just about that. So I ask you please to wait until tomorrow, the last speech. But anyway, you are right, of course, and we will have a representative of some companies, also from the UK and so on, that are involved and already signed one-to-one agreement with either NASA or someone else in order to set up a radio communication system around the moon. I know. Just please wait until the last speech. Thank you very much. Sorry.
Thank you. Our next presenter is Dr. Mario Cosmo, Science and Research Director at the Italian Space Agency, and he's going to give the ASI welcome address and prospects on moon Farside protection. So, io interrompo la mia condivisione. Se vuole condividere lei la sua presentazione o ha una presentazione, se no la trasmetto direttamente sullo schermo. Dottor Cosmo, mi sente? Io lo vedo sul mio schermo. Dottor Cosmo è al microfono spento. Saprei.
Pronto?
Ok, adesso la sentiamo. Ok. Condivido. No, non in quel senso. Cioè devi farlo andare lì, perché non lo vedi. Riusciamo a trasmetterlo anche sul proiettore? Ok, vediamo se... Chiedo scusa. Grazie. Solo qualche minuto, dottor Cosmo, perché abbiamo qualche problema nella trasmissione del video. Sì. Non c'è PowerPoint, è solo una condivisione su Zoom. Just a few minutes, we are having issues with the video transmission. non c'è il PowerPoint, non è il PowerPoint, è un...
Perché esatto, sta bloccando qualche cosa, però non so dove sia. O magari esatto è questo. Adesso
ok.
sempre su Zoom attiva. Ok, perfetto.
Ok. Dottor Cosmo? Mi sente? Dottor Cosmo? Had I known it in advance? Had I known it in advance, there was more time for questions. We are trying to reach him out on the phone.
Qui, Andrea? Ah?
Sto qui con l'organizzatore, Luca, sto col direttore. Luca? Sì. Fare?
Dottor Cosmo mi sente? Noi la sentiamo.
Can you hear me?
Yeah, we can hear you. The stage is yours. The next speaker is, again, let me introduce him, is Dr.
Hello?
Mario Cosmo, Science and Research Director at the Italian Space Agency.
Hello?
Mi sente, Dottor Cosmo? Sì.
Scusa, posso parlare un attimo?
Volentieri.
Allora.
Yes, good morning. I'm sorry for the delay.
Dottor Cosmo?
Unfortunately, you know, traffic is something you cannot predict in Rome. But, I'm sorry, I'd like to be with you this morning, but I can't. So I bring you, thank you for inviting me for this welcome. And I'd like to be with you and listen, you know, the rest of the presentations. What to say about, you know, the moon Farside? It's something even at ASI we are thinking about it. And it's important that, it's part of our planning for our future lunar endeavors. And soon we'll be talking again with our NASA colleagues about what to do together in the Artemis project. It's important to keep an eye on the moon Farside. We are interested in the radio astronomy. We are interested in the cratering history, and we are working, and pretty soon there will be workshops about science on the moon, and the Farside will be one of the sessions. So hopefully keep an eye on our website, because we need to understand also what science you'd be interested in doing. One warning. I am already seeing that the South Pole is becoming a little crowded, and so with the Farside, to take advantage of these, unique characteristics just around the corner from Earth, if we want to use it as, a scientific platform, we have to be very careful on the planning, and we don't want to make it look like as the South Pole, as the traffic I encountered this morning. I wish you a great conference. If possible, I'd be interested in the proceedings, and our sponsorship was a meaning that we are interested in whatever happens about the moon, about your thinking, your reason, to keep into account what planning we need to do in the next decade. So have a great conference, and sorry not to be there with you. Bye-bye.
Thank you very much, Dr. Cosmo. Thank you very much. Now is the first break. It's 10:50. We'll get back in 30 minutes for the continuation of this symposium. Thank you so much.
Did you get my talk?
Let me check.
I emailed it last night.
I think so. I think I remember you. No, maybe that is not necessary. Let's check. Carrera, Elvis Martin. Sì, chiedo scusa, da qui vicino, qui a fianco. Si esce qui a fianco c'è il coffee break.
I think I put my name in front of it. Maybe it's just easier to
No,
take
it's because I downloaded it.
quindi con il PDF se fai proprio clic su ok, quindi fare apri con allo ma magari possiamo fare un'ora, un table di pranzo e lui interviene se dire qualcosa non va bene. Adesso ti presenta poi scusa le spalle apri la faccia invece Okay, I think we can start with the second session after the coffee break. Good morning. I'm going to introduce the next speakers before lunchtime. So some speakers have already talked and introduced themselves in the previous session. So I would like to invite Ms. Lorena Nicotera for her talk. She's a Master of Science in Astronomy at the University of Groningen. And she works for the International Astronomical Union. So I would like to invite you to introduce your talk, whose title is Astronomy from the Moon Seeks a New Lunar Policy. You're welcome, the stage is yours. Thank you. If you want, puoi usare questo per andare avanti, indietro.
Oppure questa.
Sì, è questo per puntare.
Grazie mille.
Grazie.
Good morning, everyone, and many thanks to the organizers of this event for inviting me to the first symposium of the International Academy of Astronautics on moon Farside protection. I am glad to participate in this very stimulating discussion. As a master's student in astronomy at the University of Groningen, I did my final thesis in collaboration with the International Astronomical Union about astronomy from the moon. Therefore, I investigated the high-impact astronomical objectives that could especially benefit from some unique lunar locations. And I also surveyed the promising scientific missions planned to be brought to the moon in the next decades according to their goals, as well as I analyzed the policy framework covering the access to outer space, including cislunar space. And here today I will mostly focus on the policy part of my project, but I will briefly mention the scientific importance of the far side of the moon and the different interests in lunar Farside resources before I talk about existing policies upon the use of lunar space and the different interpretations of the international law and their implications. And then what actions will astronomers need to take to preserve the most valuable lunar sites for science in order to prevent them from the harmful interference of other commercial and governmental activities. So, first of all, the far side of the moon is shielded from radio interference by radio sources on Earth and in Earth orbit, therefore is a radio-quiet environment, which makes it the optimal place to perform very low-frequency radio observations that could also lead to the detection of the 21-centimeter hydrogen signal belonging to the Dark Ages to study epochs before the formation of stars and galaxies. And this is of extraordinary importance for cosmology to understand the early cosmic epochs, as well as to test the model we currently use to describe our universe. And the potential cosmology achievements might also be a breakthrough for fundamental physics, elucidating the nature of dark energy. In particular, there are some large areas of smooth terrain on the far side of the moon that are considered as sites of extraordinary scientific importance, as they have the geological and environmental characteristics that make them optimal locations to accommodate very sensitive radio telescopes. The most prominent are here labeled in this figure. The most promising for cosmology are also indicated with the circle symbol. And however, these same locations are also concentrated in valuable raw materials, including water and minerals, which means that they are also targeted by commercial missions that are driven by the value and possible profitability of lunar resources in the long-term lunar exploration plan. And Mare Moscoviensis is one example because it is considered as the most promising for cosmology, although it also has a high concentration of helium-3, thus providing an example of conflicting goals. And this will result in overcrowding the cislunar landscape for conflicting activities. Therefore, this also calls for an urgent intervention of the astronomical community to defend their golden opportunity of doing astrophysics from the moon. In fact, mining activity will likely pollute the whole environment, reducing its scientific value, as well as landing rockets are a threat to science, but especially on the far side of the moon, the electromagnetic noise leakage from instrumentation, either on board satellites or off-surface facility, represent the main issue of concern. In fact, this artificial radio interference will sum to the unavoidable galactic foreground, hindering the much desired target signal. And in this context, it is crucial to understand what is the noise level that experiments can tolerate before they become obsolete. And here in this schema, I wanted to summarize the actors that I identified as the most interested in lunar operations. Space agencies are interested in these very unique lunar sites for different purposes. On the one hand, they aim at testing their capacities to sustain a long-term presence on the moon, and in doing so, they also partner with private companies that are key players in the emerging lunar economy as they provide services like transport or mining. On the other hand, space agencies might also want to support scientific research for unprecedented discoveries, but they mostly aim at maximizing the use of raw materials on the moon to prepare for future deep space missions, for example, onto Mars. While the UN COPUOS is the only authority with decisional power and that could regulate the use of lunar resources for common benefit, with the view of also protecting the highly valuable lunar sites for science. The International Astronomical Union shares its interest in the protection of the most valuable lunar sites for science with other professional societies like the IAA and non-profits, but the IAU is the largest astronomical organization. It is worldwide, it is already connected with the UN COPUOS and also involved in science and policy matters for a long time. Therefore, it will likely play a very significant role in getting the consideration of the preservation of lunar seises by the committee soon. And in this context, the cooperation with other organizations is key to eliciting the science needs and communicate them to commercial actors and policymakers with the view of also achieving some agreements. So something about a policy framework covering the access to outer space. The 1967 Outer Space Treaty still represents the main international law, and the 1979 Moon Agreement consolidated principles in the OST. However, it is not in force anymore. And in the case of the allocation of radio frequencies, the radio regulations of the International Telecommunication Union complete the regulatory framework. The Rescue Agreement, Liability Convention, and Registration Convention recall and re-elaborate principles in the Outer Space Treaty. But the return interest in both robotic and manned presence on the moon pose challenges with the 2020 Artemis Accords that introduce innovation and also some uncertainties in the lunar governance. I will touch briefly the crucial points of each set of provisions individually. So, the radio regulations of the ITU represent an international treaty as they coordinate the global use of radio spectrum. ITU works also includes the allocation of frequencies to radio astronomy, as well as they participate in assigning orbits to satellites. And these regulations recognize the unique value of the far side of the moon as the perfect place to perform low-frequency radio observations in the very low-frequency regime. In fact, Article 22 declares the far side of the Moon as an area with great potential and claims its protection from radio noise. So basically, this provision entitles radio astronomy and other space research to use all frequencies on the far side of the Moon, with the exemptions of those needed to relay satellites to transmit data to Earth. However, as the main issue of concern is represented by the artificial radio interference of all instruments as an aggregate, it is absolutely important that the scientific community, the competent authorities, and the ITU collaborate to set up technical standards for all activities in cislunar space to avoid that scientific experiments cannot be conducted anymore. Well, the Outer Space Treaty comprises 17 principles that promote peaceful purposes and non-appropriation of celestial territories, but they were written when space travel was still in its infancy. Therefore, they are more formulated as general principles, and they do not clearly specify how to use this principle to govern the access to outer space resources. For example, while Article 2 literally states that outer space is not subject to national appropriation by any means, on the other hand, there is no prohibition on putting installations on the Moon. Therefore, this pair of statements makes it obvious to ask for how long are states parties to the treaties entitled to use their installations on the Moon before it becomes national appropriation. Or, for example, Article 12 states the importance of the value of reciprocity, so the free access to all facilities on the Moon by all states, while Article 9 concerns the importance of avoiding harmful interference among states, saying that they all should act with due regard to one another. Therefore, there are specific conditions to access other spaces. And in this blurry framework, what's the limit of the free access and what is considered harmful interference? And the last point is that the Outer Space Treaty does not include a provision that prioritizes scientific research over other utilization. However, the values of peaceful exploration and non-appropriation of resources and due regard could be used as the basis for defining a process for the protection of SESIs, in this case lunar SESIs. And in this framework, it is crucial to ask for a UN COPUOS resolution as a practical realization of the principles in the Outer Space Treaty. And then the Artemis Accords represent a modern effort to promote an international policy that is grounded in the Outer Space Treaty, but that reflects at the same time the potentialities and aspirations of a technologically advanced society. And they are the legal vehicles of the Artemis program, through which NASA is leading a new long-term presence on the Moon with unprecedented objectives, and that will mark a new era of space travel. And even if they are grounded in the international law, in a deep analysis, they appear highly innovative and they can be read with a controversial tone. In fact, while Section 10 on space resources states the importance that resource extraction and utilization should not translate into national appropriation, like principles in the Outer Space Treaty, the following section on the confliction of space activities introduces the concept of safety zones. And in a safety zones, the recipient signatory state is allowed to perform all its activities without external influence, but still communicating the main findings. So the safety zones is a mechanism that attempts to regulate the use of space resources in a globally agreed environment. However, it leaves space for ambiguity and disparity. In fact, safety zones may be used to legitimize the private ownership of resources or to favor the emerging spacefaring states and to exclude the others. And this is incompatible with principles in the Outer Space Treaty. And for the science focus, the Artemis Accords pay major consideration to commercial rather than scientific activities. However, they briefly mention the importance of scientific discoveries. The main finding of this policy analysis is that the existing law covering the access to outer space does not clearly protect and prioritize science, in this case lunar science, but scientific and commercial activities cannot share spaces. They need their own exclusive zones, And in particular, there should be zones exclusively dedicated to science, and they should be globally regulated and agreed. But also, it is important to know that the mechanism of all mission will break the radio silence of the far side of the moon, which means it is urgent to act to preserve the radio silence of some unique areas, and a new governance structure is needed tailored to the contemporary situation, and that can regulate all different activities and also solve conflicts. So, as I completed the scientific and policy analysis during my project, I then came up with my advice to the organization, the IAU, that being the largest astronomical community should be the place to collect the consensus on the lunar sites that need priority for protection in the near and long term. And they should create technical standards for all operational instruments as an aggregate to avoid interfering with the target signal of the very sensitive radio experiments. And these all should be done within an ad hoc working group for lunar science. And then I also advised the IAU to set up an interface with and talk to commercial industry and space agencies on behalf of science to make sure their plans are aware of the scientific needs, and align with other professional societies, and through its observer status, the IAU should take a leading position to approach the UN corpus to get the consideration of the preservation of lunar astronomy by the committee soon. So following this advice, the IAU Working Group on Astronomy on the Moon was established in 2023, and it is chaired by Richard Green, Martin Elvis, who are here today, and Christopher Johnson, and it is part of Commission B7 as a natural extension of its mission to protect existing and promising observatory sites. Has the IAU really recognized that good astronomical sites are rare no matter where they are located, and the very special ones on the moon should be protected by a dedicated international policy. And even if it has been operational for a few months, this new working group on astronomy on the moon is active on multiple fronts with different goals. First of all, to protect the unique ability to perform radio observations in the shielded zone of the moon, as well as they also want to preserve some lunar sites of extraordinary scientific importance for other astronomical objectives, for example, infrared observations or the detection of the GR's gravitational waves. And this working group is committed to cislunar astronomy needs, to communicate cislunar astronomy needs and threats to policymakers and agencies, as well as to support the IAU to get the consideration of lunar preservation by the UN corpus and other bodies. And just to conclude, even if the IAU has only recently considered lunar preservation, it already has a very consistent plan of actions. And thanks to its connections, its influence, and especially with the collaboration with other organizations like the International Academy of Astronautics, that has raised a very important awareness in a multidisciplinary setting, they will for sure make an impact on encouraging lunar research and especially for the achievement of a new lunar policy. And I thank you very much.
Thank you, Lorena, for your presentation. So we have time for questions. Let me see if I can switch the microphone on.
Hi, thank you very much for this very interesting presentation. I think also very aligned with a lot of efforts that are going on in the international arena on this topic, which is, I would say, of critical importance. My question is a bit provocative, so just forgive me for that, because we were discussing also this in the coffee break with a few colleagues, and I was, as a lawyer, I was pointing out, if you agree on the idea that there should be zones exclusively reserved for science, you are maybe indirectly, or maybe without even thinking about it, possibly creating a precedent for doing the same with commercial activities. So are you worried about this backfiring on science, or I would say on the international community? Because once we set the principle that we can violate the principle of free access, which says that everyone can go everywhere on the moon without the need to ask for permission or without the possibility of being prohibited from going, even if you do it for science, someone can use that precedent to say, then we're going to do it for mining as well, and this would possibly break apart the non-appropriation principle and therefore the, let's say, peaceful uses of the moon. So I'm wondering if you have thought about this potential unintended consequences, and how would you address them?
Thank you very much for this very interesting and provoking question. Yes, well, during the process of doing my master project, I discussed a lot also with my supervisor about this. And of course, I agree with your statement. On the other hand, since there are these very unique scientific objectives that could be achieved only in specific, in this case, only from a very few places, it should be possible to, I don't know, maybe come up with a negotiation, an agreement to devote some sites only for science, because, yeah, of course, it is the same as saying that other zones are exclusively dedicated to other activities, but maybe the most valuable for science should be really devoted only to science because of the unique and breakthrough discoveries that they could bring.
I agree with you fully. And just like if you set these double standards, it could be also used the other way around. That is my worry.
That's true. Thank you.
Thank you. So is this working?
Yes. Yeah, it is.
All right. So Antonino, I think, I mean, we were talking about this, I'm not sure that this is correct, because the sites of special scientific importance in Antarctica, for example, these are recognized as sites of special scientific importance in Antarctica. It hasn't opened the floodgates in Antarctica for sites of special industrial importance. So I think science does have, I think as scientists we should push back a little bit. International law does recognize sites of special scientific interest to be important. Well, I did ask if it was working. Can you not hear me? So I think sites of special scientific importance are recognized in international law, and there is a case for identifying them on the moon without fearing that it will open the floodgates for sites of special industrial activity or something like that.
Ian, you make a very valid point with Antarctica, right? But it's a different legal regime. And we came up with the idea of having specific scientific zones on Antarctica after 50 years of development under the Antarctic Treaty. When the Antarctic Treaty system started, there was no such thing, and there was still the question whether Antarctica was going to be used for commercial purposes. Then a moratorium on the extraction of resources arrived more than 40 years later, and in between there have been other 3 treaties that reached the system. Whereas in the Outer Space Treaty, we are still at the starting point. It's like Antarctica 50 years ago, where we don't know and we haven't decided that we want to prioritize science over commerce. The Outer Space Treaty doesn't do that. Whereas the Antarctic Treaty now says Antarctica is a scientific reserve and we prioritize science. But we haven't reached that point for the moon, and I don't think we'll reach it because there is no consensus on this idea of putting science first. And so if you're missing that premise, that you say this environment is specially for this, then it becomes more difficult to have this double standard. That's what I'm saying. Then if we reach it, potentially it would be good, but it's a different legal environment. It is true that it happened, but it's different.
Can I just say, let's not surrender prematurely. I think we shouldn't give up, otherwise it'll just become a self-fulfilling prophecy that we can't regulate the moon because no one will agree to regulate the moon. So I think we shouldn't let it become a self-fulfilling prophecy. But I think Martin wanted to say something.
Sorry to take the action away from Lorena, but I did. No? Hello? Oh, very near my mouth. Okay. Bit aggressive. If you look at the distribution of possible resources on the moon for commercial exploitation, they are also found in a similarly small number of small areas and where there are high concentrations. And because there are so few, and the best ones will always be the target of all the companies. or all the national bases. And so there will be a competition for the best spots very quickly. And so it's good that we can bring out the scientific ones and put them in up front, but I think Antonino's completely correct. It will set a precedent. I think there will be commercial incentive to have such a precedent, because if you have done the work of prospecting an area and you find that's the place to go, then you've invested half of your VC money, your venture capital money, in that investigation. Then you don't have as much left for the actual mining. So another company can come along and say, thank you very much for finding this. I've got a much bigger mining machine and we'll eat this place up much quicker than you. Ha ha. So there's a lot of incentive for mining companies to have a regime in place which gives some kind of mineral rights for at least for a limited periods.
I think Lorena was really onto something when she says we have to find a way of negotiating with all parties in order to make that happen, because non-appropriation is the real bedrock of the Outer Space Treaty, and there's one example we have where it is appropriation in a sense. It's a very limited resource, and there's international agreement that there's a fair process by which people can gain exclusive access to that resource. So it's not on the moon, it's geocentric orbit where there are locked positions that you have to compete for to put your satellite up there and be able to address your country. And everyone agrees, if your satellite's there, no one else can go there. But there's an international process that's judged to be competitive and fair by which you can actually get a limited resource and use it for yourself. So it's stretching the notion that you can go anywhere and have equal access, but if everyone agrees there's a process that works, I think that's what we need to aim for.
Is there any other question? I think no.
There is a very recent book on the subject entitled Who Owns the Moon? Which, by the way, if I understood correctly, it's not written by a scientist, but by a philosopher. So, and for those who would like to read in Italian, there is a recent book by Simonetta Di Pippo, Luna, Laboratorio di Pace, a peace laboratory, where Simonetta addresses all the problem linked to the lack of laws, lack of agreed treaties. So maybe they could be added, Lorena, to your references.
Yes, absolutely.
May you present yourself?
Yes, I'm Patrizia Caraveo. I'm a scientist from the Italian National Astrophysical Institute.
Is there any other question for us? Okay, thank you.
Thank you. Thank you very much. Questo è meglio solo per YouTube, tanto io faccio questo. Okay, so let's move on to the next talk. But before going on with the technical session, since I see Dr. Patrizia Caraveo, I would like to invite her here on the stage for her welcome address, if you like. Ha una presentazione? Sì. Carichiamo la presentazione.
Ma hai detto che c'era già?
Sì, sì. PDF, PPT, uguale.
Stesso.
Di nulla.
Quello che ti viene prima.
PDF.
Vuole usare questo oppure questo per andare avanti?
questo
Questo
è
è il laser.
il laser. Okay, so I am here. I should have been here before, but I had personal problems, and so I could not catch the early train. But it is my pleasure to welcome all the participants on behalf of the Istituto Nazionale di Astrofisica, INAF. INAF does have 17 institute and observatory in Italy, and it's a reality deeply involved in national and international collaboration. We do more or less, we cover all the subject linked to astrophysics from the ground and from space, and moreover we have departments dedicated to development of technology, spanning from radio waves to gamma rays. So we are really covering all the possible electromagnetic domain. So INAF is active and involved in study stars and galaxies, in doing cosmology, in doing planetary science, which is the subject most related to today's meeting. We are very active in studying exoplanets from the ground and from space. And we are very good in doing high-energy astrophysics because I am involved on this subject, and so I am very partial toward it. And again, we do a lot of technology. So we are present all over Italy. As you see here, the big circles are radio telescope in Sardinia, in Medicina, and here the Noto one. The Sardinia one we'll be talking about in a moment. The small circles are optical instruments, which are used both for research but very much also for public outreach, because our real optical instrument is the Telescopio Nazionale Galileo in the Canary Island, and moreover we have a share on the binocular telescope in Arizona, and of course, we belong to the European Southern Observatory, and as such, we can access the ESO facilities. These two places in South Africa and in Australia are where the square kilometer array telescope, radio telescope is being built. Moreover, INAF is also an important stakeholder on the Cherenkov telescope array, which will be built both in the Canary Island and at ESO premises in Chile. So will be our next big telescopes for very high energy gamma rays. In Tenerife, INAF is also building its own small but powerful Cherenkov array to test new technologies. So this is what happened on the ground, and then we use satellites a lot to do all kind of astronomy that cannot be done from the ground, and of course our next goal is the moon. Putting Italian instrument on the moon, and INAF is coordinating a big project which is being funded with this strange acronym here. It's the money coming from the resilience funding which Italy is receiving from Europe. As a matter of fact, INAF is doing a number of projects using these funds, and Francesca Esposito is coordinating the lunar project. It's a comprehensive project, Moon to Mars, but let's talk about the Moon. What we want to do is consider the Moon a privileged site to observe Earth and the universe. So the project foresees instruments to do astronomy, to do cosmology, and to do Earth observation. And as you are seeing here, the project is a collaboration between INAF, ASI, so the Italian Space Agency, and CNR, the National Research Council. The total budget is not negligible for a study phase. 30 million is peanuts if you consider doing the real stuff. But one has always to start with some seed money. And the idea is once again to start from the ground, to start make more powerful the Sardinia radio telescope, which has been conceived from the beginning as a dual radio telescope capable of course, doing classical radio astronomy, but also to do deep space communication. So improving the deep space communication parts to make Sardinia Radio Telescope a very important asset to talk with experiment and possibly with people on the moon, and then to explore the capability of the moon as a multi-purpose research laboratory, blah, blah, blah. So, of course, INAF is interested in protecting the moon, since to be a competitive place to do competitive science, the moon should be protected, should not be polluted, and the chapter of pollution is it's very important to us, since, for instance, one of the instruments this project is studying, it's an innovative X and gamma ray telescope to be put on the lunar surface. And once again, you don't want around any kind of strange particles levitating in the sky or whatever. So that should be a permanent observatory on the moon, and the location should be selected in a wise way in order to get the best view of the majority of the sky you want to monitor. But that's one instrument, and so there is another one, an optical polarimeter for interstellar polarization survey. Once again, the colleagues who are doing this want to exploit the lack of atmosphere on the moon, and so to have a view as clear as possible of the cosmos. And another instrument is dedicated to Earth observation, so monitoring the brightness temperature of the Earth as a unity. And we are also studying a possibility to build a panoramic camera to always monitor the behavior of a vast fraction of the sky from the moon. So you see that the possible interests are very many, not forgetting about the possibility to be present in a lunar village, or whatever you want to call a permanent place where human could live and work on the moon. But INAF in this is not a leader. The leader is the Italian Space Agency, of course, but we provide all the scientific support on all this. So that's what INAF is doing vis-à-vis to the moon, and let me remind that INAF is also a partner on a institution at the Bocconi University. It's called the Space Economy Evolution Laboratory, C-Lab, which is dedicated to space economy, but it's a space economy which is respectful of the need for international treaties, respectful of the need of scientists, and so that's why INAF is a partner on this laboratory to provide all the scientific support which is needed to develop a space economy which is also very respectful of the lunar ecology. Thank you.
Thank you, Patrizia. Then we can go on with the technical session. And sorry? Yep. And I would like to invite the next speaker, which is Dr. Catherine Sham, to the stage. Is new? Okay. I think she's speaking with Nicolo. Okay, not now. Okay, so we move on with the next speaker. I don't know if he is online actually, since yep. Okay, sorry for the misunderstanding. Okay, so no, yeah, it's the time for the talk by Dr. Catherine Sham. Okay, I would like to invite you to the stage. She's a NASA Lunar and Human Spaceflight Spectrum Manager and chair of the Space Frequency Coordination Group. So thank you for being here. And just the time to upload the presentation, and then the stage is yours. The title of the talk is The Spectrum Planning to Enable Cislunar Science and Exploration. Thank you.
Thank you very much for having me today. And my name is Kathy Sham. I work for NASA, and I am currently serving in the role within NASA as the spectrum manager responsible for our human spaceflight programs and also lunar missions, including those that someone had mentioned earlier, the commercial lunar lander missions. So, and additionally, just as a part of my introduction, that I also work closely with our space agency partners in the Space Frequency Coordination Group. And actually today, in my presentation, I will talk about the SFCG. The reason for that is also because the current acting executive secretary of SFCG, who is our new Working Party 7C chairman, we are currently in our meeting, our first meeting of the study cycle in Geneva. And so he has asked me to talk about the Space Frequency Coordination Group activities as well. So I have embedded that information in my presentation. And my role within the SFCG has been the coordinator, the chair of the Lunar Mars Spectrum Planning Group. So for many years now that we within the SFCG have been discussing radio frequency spectrums that our missions should be using for our missions around the moon, on Mars, around Mars, or other planetary bodies. And more recently, we have started discussing the importance of the shielded zone on the moon because of all the activities that are being envisioned. And actually, we already have China, India, Japan, and other spacefaring nations that's already started that activity. So with that, let me move on to my presentation. And I think, am I using this?
Yes, yes.
Okay, so do I just? Yep. Okay. So as I indicated earlier, that recognizing the importance of the moon for scientific activities, and the fact that when we envision a mission to the moon, there's gonna have to be radio frequency activities going on. If not for anything, we wanna bring back the science that we collected from the moon. So even for radio astronomy missions, observations, we must figure out a way to bring back data. Otherwise, I guess we'll be sending all of you to the moon and leave you there to do your science. So very important aspect of trying to figure out how do we do this. Again, going back to spectrum planning, and my talk is specifically focused on radio frequency spectrum, not the other issues that are very important as well, on how to figure out who does what and who can do what. But this is just about radio frequency planning and how do we coordinate the use of radio frequency spectrum, which is also limited, not only in itself, as a natural resource, but also there is the ITU, and there's the radio regulation, the International Treaty on Spectrum Use. what can be used and what are protected. So all of that we have to take into consideration. So one of the things that we have been doing is between the space agencies in particular for the many years leading to now, including our collaboration with our own commercial partners. Because today, many of the commercial companies that are envisioning going to the moon or are going to the moon or have been is a partner with space agencies right now. And we recognize that from the standpoint of technology development, it is not just the space agencies. There's a lot of different innovations out there which really necessitates the space agencies to cooperate and collaborate with universities, with private companies that have invested in different technology. We don't need to reinvent the wheel if we really wanted to go, because it costs a lot of money, and we all don't need to just do our own things. So that is another thing that has, from a NASA perspective, definitely, and I think with our international partners, space agency partners, we have recognized that for many years now, that we have collaborations with our industry partners. So the Space Frequency Coordination Group, I mentioned earlier, we have actually, the past couple years, and I see the third bullet here, Space Frequency Coordination Group, SFCG. I mentioned here an administrative resolution that we have agreed upon a few years back, our 40th meeting, and many years ago that NASA, ESA, JAXA, and a few other space agencies envisioned the need to cooperate. Back then, in 1980, I believe, a few agencies got together and decided that, hey, we share frequencies. We use frequencies that are allocated through the radio regulations for space research or space operation, for example. We share frequencies and we're gonna go do our mission in space or planetary deep space. Because we share, we have to make sure that we don't cause interference with each other. And more importantly, is there a way to cooperate so that we actually share each other's resources? So our signal structures can be received by another space agency's asset. So we individually do not have to put all of our resources or money and talent all over the world in order to do a mission. So, Space Frequency Coordination Group a few years ago have reached an agreement to serve individual space agencies, serve as basically a way for their individual national commercial or industry or academia community in that administration to go through the space agencies to basically coordinate uses of spectrum. So we have tried to extend that, and really this is really all primarily for scientific reasons, because we recognize that if there's not a way to pre-coordinate technically early on, it costs a lot of money. Once equipments are built, or if they're launched, it's hard to bring those back. So Space Frequency Coordination Group have made those efforts to try to extend the just space agency coordinating together, extending those beyond, but using the space agency, individual space agencies in their administration to work within their own domestic environment. So, so that is one thing that we have done within the Space Frequency Coordination Group, and through this administrative resolution, NASA have offered to provide technical assistance, which is the lunar spectrum management role, and that's the role that I have currently within NASA to help with the technical aspect of coordinating uses of frequencies and ensuring that we have a set of frequencies that have been agreed and also in compliance with the radio regulations, or that we take steps to ensure that we, in the future, secure protection for those frequencies through the appropriate means within the ITU. So that is something that is currently happening, and the reason why NASA is doing this is because through our International Space Station experiences, that we recognize that these early technical coordination was valuable so that we as multinational and having to actually making sure that we comply with the domestic rule as well as international rule, that we could work together first in an environment that's collegial, and it's not, I guess, perhaps this is a provocative thing to say, is not political, that we just work at the technical level and making sure that our science and our operations of a space platform can be, our missions can be accomplished. So that is one of the reasons that NASA have made this offer through the Space Frequency Coordination Group to provide the technical assistance if necessary. And obviously, individual space agencies in their domestic setting, they can also provide that technical assistance and work with their domestic partners. So with that, let me go on to the next group. And here's the Space Frequency Coordination Group's overview. And I'm not going to read it, but as you can see here, that we have many, the members are civil space agencies. And some may ask, why not more than civil space agencies? And one of the reasons for this is because we are wanting to make sure that it is definitely space science focused. We recognize that there's a lot of other uses in space, but in particular, the focus of the Space Frequency Coordination Group is about science, space science. So, and also that in particular, the focus is on sharing of frequencies that are allocated to specific space services. And you see here on the slide that it's space research service allocations, space operations service allocations, Earth exploration satellite, and meteorological satellite, and in some cases, inter-satellite services that are dedicated for space research purpose. So these are the frequency allocations that is of the concern of Space Frequency Coordination Group. We are not dealing with, for example, fixed satellite uses or terrestrial fixed and mobile uses. There are certainly sharing studies that are performed as it deemed necessary, but basically the advocacy of the Space Frequency Coordination Group is to advocate for uses of, for the purpose of space science in these allocations for the protection of these uses, and also to ensure that our own missions in particular, and missions that we are dealing with, that actually complies with existing regulations as we design the system and operate the system, because as we heard already, that there are many issues, and we do see interference in our missions today. Some of it is expected, some of them are not expected due to potentially other design or potentially equipment aging issues, etc. But specifically, I wanted to make sure that I convey to all of you that what Space Frequency Coordination Group is about, and also that for all of you here that actually, if you're interested, I could provide to the group memberships to the SFCG, and ASI is a long-standing member of Space Frequency Coordination Group, and China also very active in participating in Space Frequency Coordination Group. So India, France, CNES, DLR, so many space agencies are members of the Space Frequency Coordination Group. So there's certainly lots of opportunities for individual participants here and organizations to be able to connect with your space agency, who can bring your topic and your issues to the Space Frequency Coordination Group. And our next meeting actually is in June, and we have been invited by Israel to come to India. So the meeting will be coming up soon, and it is annually that we meet. And so I would encourage all of you to reach out to your individual space agency, point of contact, and I can provide that, so you could work with the SFCG. And here, just a few things that I wanted to highlight is that over the last few years, recognizing the rapid evolvement of many different activities that are looking at going to the moon, here are some of the outputs from the SFCG. SFCG, I mentioned already earlier, the A40-1 is the administrative resolution. It's the assistance of providing assignment of frequencies for mission to the lunar region. And we also have here that SFCG recommendation 32-2R5, revision 5, and we may be revising it again this coming June, depending on the input contribution. In particular, over the last few years, the evolvement actually has this recommendation started out as only for communications, but we have added over the last few years frequencies that were studied and agreed by membership to be used for lunar in situ point PNT service. So that is aside from the existing capabilities that we have today around the Earth, for example, GPS or Galileo, etc. We envision that down the road that there would have to be some sort of lunar orbiting capability to provide very precision timing and navigation pointing data for missions that will be on the moon. So that would be a future capability, but taking into account that this capability would need to actually be radiating on the backside of the moon, because the instruments that are there will need to have time, most likely. So we want to make sure that frequencies that we are looking to implement this capability do not cause interference to radio astronomy observations. So SFCG have agreed on a frequency range for this type of capability, and it is currently being studied as part of the World Radio Conference 27 agenda item 1.15. So because this frequency range actually currently do not have a proper allocation, have no protection if we were just to use it. We want to make sure that there are regulatory protection and that we use the proper frequencies that is in the radio regulation. So action were taken. Over the last few years, we went to World Radio Conference 23, and we now have an agenda item that will allow us to study and eventually at WRC 27 to get allocations for space research service to be able to enable surface communications and also some of the orbit to surface links, which includes this capability that I just talked about. But it all started out from a technical perspective, was studied within the Space Frequency Coordination Group and have agreement amongst the space agencies that this is the right thing to do, so that we take that to the next step, basically. The other thing is the 23-5. We have renew our commitment to protect the shielded zone of the moon within the SFCG. And this is a resolution, 23-5, that we have updated during last year's SFCG. So that was very important to all of us to make sure that this is up in the forefront of our mind, that whatever operations that we go and use from a spectrum perspective, that we do make sure that we do not pollute the environment on the backside of the moon. And this next page is some additional outputs of the SFCG that includes how do we best efficiently use the spectrum amongst all the missions that will be going to the lunar vicinity, either operating on the surface or the moon, and how would they operate, how would they communicate back to Earth. There's also frequency channels for the data relay links or within the in situ. Just like today, we have data relay network around the Earth to provide capabilities for Earth orbiting satellites. We envision the same thing, what happened around the moon. So we do have initiated work there to ensure that there are channel plans so that in the future, there is a way to cooperatively operate without interference, and also, more importantly, the capability of interoperability. That if we operate on a channel plan, that while some of the satellites may be servicing a specific spacecraft on a specific channel, it actually will have the capability across the board for all the channels, so that if another satellite needed help or an emergency situation, that it could actually rely on another satellite. So it's both for compatibility and interoperability purpose. And the last item is something that we anticipate would be something that will be to come. And this is probably something that radio astronomers do not want to hear, is active remote sensing around the moon. And so that is something that we're also talking about. If you are going to do active remote sensing, what are the correct frequencies for you to use so that you don't disturb the pristine environment of the moon? All right, so here about LunarNet interoperability spec is today, NASA, JAXA, and ESA have agreed to cooperate and collaborate on a standard that we will collectively use and move forward. And we also envision that potentially there would be commercial satellites who wanted to provide service that could use the same protocol and the channel plan. So, so this is another importance of not just governmental entities, but bringing commercial entities into this activity, but have a plan to ensure we all are marching on the same sheet of music. Here is just for your information. There's lots of spectrum and channels and frequencies. And I hope that you can study this if you're interested, and we could definitely have offline discussions. And one of the things I talked about already, my role as NASA's Lunar Spectrum Manager, just to facilitate technical discussions and activities, and really another important thing that we're emphasizing within the agencies, individually within our respective agencies, is the design, the early design criteria, so that we comply with regulations and so that we would not cause problems in the future. And there's a portal that for systems that will be going to the moon, we actually use this capability to collect data so that we could provide assistance in frequency selection. And again, this is just for your information. We have set up a way to electronically collect data and then disseminate our analysis results back to missions that are planning their activity. This is not a regulatory activity because we recognize that individual missions falls under the jurisdictions of their domestic regulator, and that they would then file with the ITU. And here's just some key takeaways. Protection of the shielded zone, the moon, is something that is up front and center in our mind, in our design of our systems, and that we also continue to remind our missions that when they're behind the moon, they don't see their Earth station, their transmitter must be off, even if, they supposedly, there's a lot of people that read Article 22 and said, oh, we are one of the exceptions that we could operate. Yes, you can operate, but if you don't have a receiving station, you must turn off, because there's no point radiating to nobody and then cause issues with systems there that are observing. So that is something that we're definitely trying to remind everyone, and that a common lunar spectrum architecture, so that we have a way to cooperate, collaborate, and continue to ensure that we comply with the radio regulations for use of radio spectrum. Thank you.
Okay, we have 5 minutes for questions, so please.
Okay, this is very important work, obviously. Could you clarify, though, the radio astronomers really need most of the VHF band clean of any noise for Farside work. And that's not a frequency, that's a really broad frequency allocation. I don't know if you're able to consider that. And the other thing is, do you consider unintended radiation and unintended EMAN transmissions from the electronics boxes and so on?
Yes. So let me quickly address that. For as far as the radio regulation is concerned, I think Dr. Nostrom tomorrow, he will talk more about the ITU, radio regulations and the allocation, et cetera. But let me just say that today, active communications around the moon and from the moon back to Earth and from Earth to the moon, there are not actually radio allocations, radio spectrum allocations in those very low frequency bands that would have been used or can properly be used. So we are continuing to remind all the missions, and that is a reason for the SFCG recommendation, where between the space agencies, we are agreeing on only using certain radio frequency spectrums and according to what the radio regulation allows, and also that in collaboration with IUCAF and CRAFT, for example, and the ITU to determine are there some specific cases where those bands may be needed. But technically speaking, we're avoiding uses of frequency bands that are below in the low frequency like VHF, UHF region, unless they are already allocated for space research, for example. The second thing, let me really quickly address is from a NASA perspective, NASA missions, I will use the example of International Space Station. Any equipment that goes up to the International Space Station, especially, they all have to go through electromagnetics testing. So there are specific requirements for radiated emissions for even unintentional radiators. And so we are very aware of that issue. I cannot say that, I do not know internationally if there's some specific bodies that can levy those requirements, but from a NASA perspective and even our international partners today on ISS, JAXA, ESA, OSCE, Roscosmos, all have radio unintentional emissions requirements for boxes, because we have had many cases where boxes goes up and we discover something that it actually causes interference to another box or another intentional communications frequencies and having to turn it off, which is a terrible thing to do because you have spent a lot of resources to launch something into space, and we do not want to have those type of situation. So I think that would be a topic of discussion. And actually, currently, within the ITUR, Working Party 7D have a discussion going on with unintended emissions. So that may be something that can be, we could discuss off the side. And Dr. Nordstrom's also very familiar with that topic.
Before you ask your questions, I please you to present yourself.
Richard Green with the International Astronomical Union. So Martin asked a key question, so I'll ask another hard question. Commercial space world wants to have a big voice at this table, right? And so DARPA's coming in with their Luna 10 report, and they would like to be very lightly regulated and use the frequencies of their choice and convenience based on what they do now. So how strong is that voice in terms of pushing you in other directions?
Yeah, very good question. And yes, we recognize that there's a lot of different, that there's a lot of desire to leverage existing capabilities out there. Just because it works here on Earth, let's just take it into space. And we face the same thing with International Space Station, leveraging COTS capabilities, but from an International Space Station, based on our experience, is basically the program has to have a requirement, and they have to go through the testing and the showing that they will not cause interference. But more importantly, that from a filing perspective, putting something into space could affect all nations, not just your own country. So domestically, I mean, there's going to be domestic regulations, but ultimately, use of radio frequency spectrum needs to go to the ITU, so that it should not just be, oh, well, I'm only going to operate for 5 days, so I do not go through the process. Because lacking that process, we could have just anything in space. So I think that we continue to make sure that all the equipment that we're involved with that are going to be put into space go through the proper regulatory process after we complete our technical assessment. But even in the technical assessment stage, we want to make sure that we put requirements on these new developments to make sure that they understand what frequencies, especially, are allowed, what frequencies are not allowed. And without them knowing that and recognizing that there is actually authorities and that they require licensing, I think that it could be a slippery slope. So we need to make sure that we continue to speak that into everyone who we come in contact with.
I'm afraid that we have no more questions for this time. We have the other speaker online, so maybe we'll have a chance for questions later for the lunch break or coffee break. No problem.
I'll find you in the break, but thank you. This was extremely interesting.
So thanks again. So we optimize the time working in parallel. So next speaker is Professor Makoto Yoshikawa, and he will give his talk online. So we are trying to connect on Zoom. And Professor Makoto Yoshikawa is from ISIS, Institute of Space and Astronautical Science of the Japan Aerospace and Exploration Agency. So we see Professor Yoshikawa online, and please check to switch on your microphone, please, and share the screen. Okay. We see you very well. Okay, good.
Can you hear us? Professor, can you hear us?
Can you hear me? I cannot hear from you.
Yeah, we can hear you. Ah, gli ho scritto.
Okay, I cannot hear from you, but you can hear me.
Yes,
then,
we can.
I will start.
Professor Yoshikawa, can you hear us?
Okay, can I start? I cannot see the chat.
Professor Yoshikawa, can you hear us?
Sorry. Okay, then I start. I hope you can hear me. So my name is Makoto Yoshikawa from JAXA. I'm going to talk about the observations of near-Earth objects from the moon, Farside, for planetary defense. So please look at this figure. This figure is rather exaggeration, but if asteroid or comets collides with the Earth, we will have a large natural disaster. So here I show you three examples. The left one, this is a Chelyabinsk meteorite in 2013. In this case, more than 1,500 people were injured. The middle one was famous Tunguska event more than 100 years ago. In this case, about 2,000 square kilometer forest was damaged. And the left one, this is a mass extinction about 66 million years ago. So these disasters were caused by a collision by a small object. And the size is like this. Chelyabinsk meteorite, the size is just 17 meters asteroid. And Tunguska, about 60 meters. And mass extinction, this is 10 kilometers. So anyway, very small asteroid can cause a large disaster. And of course, we want to prevent such disasters in advance. So that is a planetary defense or space guard. Then what should we do for planetary defense? Step one, the important thing is to discover NEOs. NEO means near Earth object. And they have possibility to collide to the Earth. So first we must discover them, and then a follow-up observation is also very important to determine their orbit very precisely. If we can determine their orbit precisely, we can check whether they will collide with the Earth or not. And if they collide to the Earth, we can know when and where they will collide. So observation is very important. And also to investigate the physical characteristics of NEO is also very important. So for this purpose, we have sent a lot of spacecraft to small bodies of the solar system. And step two is rather difficult. Step two is to avoid collision or minimize damage. And there are several methods to avoid collisions, but they are very difficult. And I think the most good one is this kinetic impactor. I will talk this later. Anyway, when we do this, we need international coordination, and we must make international law. So planetary defense, there are lots of things to do. And this shows the current status of asteroid discovery. Up to now, more than 1,300,000 asteroids were found. And among them, NEOs are about 35,000. You can see right-hand figure. This shows the distribution of asteroids. And the red one is NEO. So you can see around the Earth orbit, the third orbit from the center, there are lots of NEOs. But we know the orbit of these NEOs, so now we know that these NEOs will not collide with the Earth in near future. But still there are lots of unknown NEOs. So please look at this figure. This figure was taken from the website of JPL, and the horizontal line shows the year, and the vertical line axis shows the cumulative number of discovered NEO. So at present, we know about 35,000 NEOs, but please look at this color. The red one shows the NEO larger than 1 kilometer, and the orange one shows the NEO larger than 140 meters, and blue one is less than 140 meters. So you understand that the red color is not increasing now. So this means that we have found almost all the NEOs larger than 1 kilometer. So that indicates that we do not worry such large event like mass extinction in near future. However, this orange one or blue one, the number is increasing. This means that there are lots of unknown NEOs. So we must discover them. And since we have found lots of NEOs, in some cases, we found asteroids before colliding with the Earth. I think there are these 8 cases. For these asteroids, they were discovered just before collide to the Earth. But the time from discovery to collision is just 20 hours or a few hours. This is very short. This is because the size of these asteroids is very small, just a few meters. So we cannot discover them until they come close to the Earth. But if the size of asteroids is much larger, then we can discover much earlier. Then, for example, if they collide to the Earth, then we can escape from the colliding point. And this shows the asteroids observed by spacecraft. Now there are lots of asteroids that spacecraft visited. And among these, the NEO is this one. There are 7 NEOs. And if I pick up only NEOs like this, so there are 7, and the left is larger and right is smaller. So EOS is very large, about 38 kilometers in length, and this right one, Dimorphos, is very small, just 160 meters. So, and in Japan, we have Hayabusa and Hayabusa 2 mission, and Hayabusa visited Itokawa. This is about 500 meters, and Hayabusa 2 visited Ryugu. The size is about 1 kilometer. And Hayabusa 2 mission is now extended, and it will visit another NEO. The first one is 2001 CC21. This is a flyby mission, and the size of this asteroid is maybe around 500 meters or so. And the final destination is very interesting. It is 1998 KY26, and the size is very small, just 30 meters. So if Hayabusa 2 can arrive at this asteroid, we can know the nature of this very small asteroid. So such small asteroids have large probability to collide to the Earth. So this mission is very important from the point of planetary defense. Okay, and how to avoid collision with the Earth? There are many methods proposed, but I think the most effective one is this one. kinetic impactor. So since today I don't have enough time, so I just show you the DART and Hera mission. This one, NASA launched DART spacecraft, and this spacecraft collided to this small asteroid, Dimorphos. And it was successful to change the orbit of this asteroid slightly. And this year, ESA will launch Hera, and Hera will visit this Didymos and Dimorphos to study in detail about the result of collision. Okay, so I go back to the collision frequency. So this graph shows the collision frequency of asteroid. The horizontal axis shows the size of asteroid. The right is small and the left is the left is small and the right is large. And the vertical axis is cumulative number or impact probability. For example, the final destination of HAVSA 2, 1998 K26, the size is about 30 meters or so. So in this case, the collision probability is about once in 100 or 200 years. Okay, and this red line shows the number of asteroids we have already found, and this blue line shows the estimated number. So for this small size region, there are lots of unknown, undiscovered asteroids. So we must find these unknown asteroids. So that's why the observation is very important. And there are two kinds of observation. One is optical observation, and the other one is radar observation. And this figure also comes from a JPL website. And now there are 8 projects that were intensively discovered the NEO. And this website is also JPL, and this is a radar observation. So optical observation, the discovery is important, and also we can determine the orbit, and we can know approximate size estimation size. And radar observation, of course, we can determine the orbit of asteroid, and we can know the accurate size of asteroid. So the observation is important, but the problem is artificial satellites. And this image shows the light from the SpaceX satellites observed at Royal Observatory. These streaks were made by the artificial satellites. So how to avoid these interference with satellites? For optical observation, short exposure time is good. If the exposure time is short, we can avoid such a streak. And radar observation, we use different frequency to avoid the interference with artificial satellite. However, if the number of satellites increase significantly, it may be difficult. It may be difficult to observe asteroids from the ground. So in this case, observation from space or the moon would be effective because we can avoid interference from satellites, and also we can avoid the atmospheric influence. So let me quickly show the JAXA's asteroid observation. JAXA has Bisei Space Lab Center, where we have 1.5 meter telescope. mainly we observe space debris from the Space Center, but also we observe asteroids. And also we have small telescopes in Japan and in Australia. And using these small telescopes, we developed new method to discover a high-speed moving object. This is a stacking method, and we take many images by short exposure, and we stack the image to find the fast-moving object. And by the experimental observation, we found more than 10 very small asteroids by this method by using very small telescope, just a 20-centimeter telescope. And I remember the discussion about 30 years ago. This is the idea of Stellarium telescope. In 1998-95, we made a plan of Stellarium telescope, which is an optical telescope that monitors the night sky approximately one stellarium with a time resolution of 0.1 seconds. So using this telescope, we observe optical transient phenomena such as gamma ray bursts, supernovae, asteroids, meteors, and space debris. So concept is like this. We put many telescopes, for example, 144 small telescope like this, and the telescopes don't move, just fixed. And the diameter is just 20 centimeter, and field of view is, the telescope field of view is 5 by 5 degrees. And we put two sets like this. Actually, similar idea was already made like this. This is a dragonfly telescope, telephoto array in New Mexico, USA. So my idea is to put this Stellarium telescope on the moon to find NEOs. And NASA has another idea, NEO surveyor. In this idea, spacecraft will be launched to L1 point here. And from here, it observes NEO in this direction and in this direction. So combining these ideas, I can draw this figure. So this is a future observation of asteroids. Of course, from the Earth, we observe asteroids from the night side of the Earth. And from the L1 point, NASA NEO surveyor will observe asteroids. And we put a telescope on the moon, then we can find lots of NEOs that is coming to the Earth. Not only far side, but also near side is good to put the telescope. So this is a if we can do like this, it is very ideal. So anyway, I think the moon is very important for the observation of asteroid for planetary defense. Okay, so that's all for my presentation. Thank you very much for your kind attention.
Let's see if it is possible to ask some questions to Professor. Okay, can you hear us? No. Professor Yoshikawa, can you hear us? No.
No, maybe Professor Yoshikawa, can you hear us?
Yes, now I can hear you.
That is my voice. It didn't work.
Okay. Any question?
Yes.
Okay.
So thank you very much, Professor Yoshikawa. I think this was a really very, very important presentation. Let me explain. Oh, yes, I am Claudio Maccone, the person who organized with co-workers this conference. Let me thank you very much for this presentation, and let me tell you why I particularly appreciate this point. Because so far, I guess only very few people thought of the advantages of doing planetary defense from the moon far side rather than from the Earth's surface. So we all know that from the Earth's surface we have this problem of the Starlink satellites and all that. So in my opinion, we should stress in a particular strong way that at the moment at least, the moon far side offers the best opportunities for planetary protection before we can possibly use it for other purposes like cosmology and astrobiology and SETI and all that. So I thank you very much because adding planetary defense is particularly significant for future progress in this field. Thank you very much.
Thank you.
Any other question?
Okay. There are no other questions, so I would like to thank again Professor Yoshikawa for your contribution and for meeting us here. So with this talk, the second session is over, so it's a lunch break, lunchtime. So we will start after lunch at 2:30. This building has a shopping mall, so if you go outside, just straight on the left, you have stairs which bring to the shopping mall. There is a food court there. There are many places for having some food and after we gather here again at 2:30 to start again with the afternoon session of the Congress. Thanks again to the audience. Okay, the room will be locked, so if you want to leave your personal belongings here, you can, because all the doors will be locked until our return. Thanks again.
Molto probabilmente. Ha il telefono spento. Gli ho telefonato ma ha il telefono spento. Shall we get started? Our next speaker is the president of the Moon Villas Association, Giuseppe Ribaldi, who is going to talk to us about the Moon Village Association contribution to international lunar coordination and cooperation. Thank you.
Okay. All right, so first of all, good afternoon, and I hope you are all awake after this big lunch. Well, I don't know if it's been big or not, but in any case. So I hope you might fall asleep, but just in case, just raise the hand, and I will try to speak a little bit louder, so to make sure that you don't sleep. So, but joke aside, first of all, thank you, of course, to the organizer of this event. I think this is important. The International Academy of Astronautics finally has managed to get involved in the moon activity. Jean-Michel, unfortunately, is not here, but I have tried to convince him several times to do activity with the moon. So I think this is who start well is at half of the work. So what I'm going to do this afternoon is to say a few words about the Moon Village Association. Some of you might know, some people are already actively involved in the organization, some others they might not. And then I will focus more the discussion about, let's say, coordination and cooperation in terms of activity which are not leading to a treaty, to be clear, but which we're going to be leading, hopefully, to what is called soft law. And we will discuss the situation in the corpus. So let me, therefore, first of all, say a few words about the organization. Well, so the Moon Village Association is the first, let's say, NGO dedicated to the moon. And this was created in 2017. And I have to say that I'm pleased that Torino has been hosting the very first meeting of the Moon Village Association. So, so you can see 7 years. And it was started in June of 2017, as you can see the word there. So the goal is to try to bring together, let's say, stakeholders, as we will see later, from all the worlds, from all type of topics in the cooperation and coordination. So we have been very soon member of the IAF and, of course, permanent observer within COPUOS. And therefore, that means that we can bring to the attention of more than 100 delegates some of the issues related to the lunar concern. And that's what we have been doing regularly, and we will discuss later. So it is a platform to bring together government, space agency, as well as international organization, NGO, but also very important, I like to say, is the public. The public is unfortunately left out from a lot of the discussion, and the public is a very key participant in those discussions, especially for what concerns the moon. Having worked 16 years on the International Space Station, I realized that the public was completely out, except for the press conference that we were making when some launches was taking place. So hopefully the moon is also giving a little bit more time and more possibility to involve the public, and that's what we do also by having, let's say, network in all the world, which about 50 network. Today we have the Italian coordinator here in the first row, Alessandro, which is organizing a lot of good activity also in Italy, including a summer school. And this year will be the second year that they will do that. So we have several countries in it, as you can see, around 64, which is not bad. Consider the COPOS is 102, so we are getting close to the full COPOS. And of course, this can be done at the level of individual, but also at the level of institution. Now, there is no intention to go through some of those activities, but this is just to show you the palettes of all kinds of activity which go from culture to the International Moon Day, which we have been proposing and was approved, as we will see later, architecture, participation of emerging countries, analog, so you name it. A lot of things which you might have in your mind is there. And of course, we invite you to look to the website. So this is just an example of the work made by the so-called Moon Village 2045 reference mission. It is the first very long study managed by John Menkins, former technologist in NASA, which has put together and defined building blocks for a future lunar, let's say, settlement, which is not involving necessarily only the West, but involving also all other countries. This is an artistic view of the landing spot, which is inside a crater, but a lot of detail are inside the actual website. So then we're also dealing with economics. It was mentioned, economics SEE earlier in the morning, and indeed we have a cooperation with SEE. We are pleased to cooperate with them about this aspect. We published about a year ago this Lunar Commerce Portfolio, which is about 200 pages report, very detailed with 9 segments of the moon market. Everybody is welcome to look, and we are planning together with SE Bocconi a workshop around the time of the IAC. Soon you will find more detail on our website. So a few words about this other activity, which I think is very important, to try to involve as much as possible participants from developing country. And so you can see there, these are the countries which basically they were involved in some of these activities. So it goes from South America to North and Central America. And so I think this is an activity which is helping them to try to enter inside the moon-related activity with what we call road mapping. Then I like also to mention the International Moon Day, because this is something which it has been basically proposed by the Moon Village Association, and this was approved. Fortunately, it was approved in a period where the politics was not so bad, and so we managed from the proposal to the approval 4 months. So in 2021, in 4 months was approved, and you can see that okay, our organization is trying to organize events around the world. You are mostly welcome to organize one event in your own region. So there is a call, as you can see, which is open on the IMD website. So in 2023, the first year, we had about 26 countries. Last year, we had 42 countries. You can see the color, which is growing specifically in Europe. And hopefully this year, we target around 60 countries, but hopefully we may even have more. So you're welcome to participate. This is an important event for the public. That's what I said. This has been done specifically for the public. Is the 20th of July. The International Moon Day has been, let's say, proposed and approved for the 20th of July, and so it is around that period, week before, week after, that around the world events are getting organized. A couple of examples of telerobotics. This is one of the events organized by American colleague. So 3 organizations have offered the possibility to drive rovers to school. And well, you can see there the numbers. I'm not going to read all the numbers. You will see also later on the presentation. But we have about 15 countries participating in this nice experience to drive a rover utilizing basically your own computer. And so this was, these are the organizations that you can see are basically participating in this event. So, but more detail you can find on the website finally, and then I'll come to the cooperation aspect. This year, we are pleased to say that we are going to be in China, in Harbin, and this is organized by the Harbin Institute of Technology, the Chinese Society of Astronautics. So I'm going to stop about the general, except this one, maybe. It is an advertising for the next workshop, which is done in Luxembourg, together with the Luxembourg Space Agency, and you can see there the week. So next week there is the Space Resources Week, and hopefully they are going to advertise our annual workshop together with other activity. Now let's come to the moon, specifically cooperation and coordination. So I think the organization realized a few years ago that basically with the increasing number of, let's say, stakeholders, there was really no coordination mechanism in order to try to, let's say, have the people talking to each other. And so we are just identifying some of the issues, but there are many more, as you can see. So in February 2021, MVA, we decided to create the so-called Global Expert Group on Sustainable Lunar Activity. The aim is what you can see there, is basically to bring together in this platform a lot of the stakeholders, and I have to say, as you will see later, we succeeded. And of course also the public. I repeat, public is always a recurrent element, at least as far as I'm concerned, and is a platform to exchange this kind of information. And so, and we have been always reporting regularly to the UN COPOS all what we do. So finally, in 2023, in January, February, we published a document, which I have still a couple of copies, but you can download it. It is a comprehensive document, 64 pages, which were made by the members of, which was made by consensus. And just to give you an idea, these are the kind of membership. So you can see that we have been able to get a team, large team, I have to say, also from China, which involved from the Ministry of Foreign Affairs to the scientists, to the industry, as well, of course, United States and other. So this basically report gives a lot of, let's say, capability and a lot of definition about what could be a potential, let's say, not treaty, because I repeat, not treaty, but what is called soft law. If you like, you can look at this as a much larger Artemis Accord. Artemis Accord were produced a little bit earlier. By the way, not many people of you might know, but the Artemis Accord was born by the same people which participated in the International The Hague Space Resources Working Group, which I had the pleasure to be the executive secretary. Mike Gold and all these people that they were at the root of the Artemis Accord got inspired by the Hague Space Resource. So in some aspect, we are responsible to the Artemis Accord, which I think in any case is an excellent document. So therefore, what is this recommended framework? So I'm not going to read all of that, but basically it indicates what could be the way of behavior, is basically behavior of stakeholder in operating on the moon and around the moon. So basically, of course, it's using all what is available on the existing treaty, and let's say is a living document, because these 64 pages, of course, they are meant to be evolving. And of course, we have regularly provided all this information to the United Nations COPOS. Again, this is not going in detail, so there are two parts. The part I want to zoom in, and I will zoom in the conclusion, is the chapter 6, relevant for this meeting, which is basically a chapter related to safe operation and lunar environmental protection. So there is quite a bit about this, and as you will see later, there is a specific paragraph related to a site of specific scientific interest, which is what we are talking today. So there is a lot of data about what needs to be done. You can see from the title of the chapter, there is a lot of work which has been made. And I have to say, beside this document, we managed to produce also 2 annexes. And one of them, guess what, is basically related to the sustainable management of lunar and natural cultural heritage, as well as an environmental assessment. These are two large documents produced specifically from Alice Gorman from Australia. So beside this framework document, there has been also quite a lot of information on the two annex, which if you are interested, I invite you to see, you can download it. Coming more to the present, so in January, when GESLA published the result, we decided to enter an operational phase, which basically with the goal to operationalize the framework document and support the corpus discussion. As you can see in a moment, they have paid very well for this. We have created 3 working groups. Well, you can see one of the co-chair of the working group, Ian, it's here, and he's going to talk after me, and I would like to zoom in a moment on that. So 3 working groups: lunar environmental protection, lunar technical coordination, mainly dealing with industry, as well as lunar multi-stakeholder coordination, which is more the policy relevant working group. Again, you can find all of this information. So the environmental protection working group, which Ian is going to say a few words, needs to define site of special scientific interest. And of course, the moon Farside, for instance, is obviously one of them. So we had some early discussion only this morning, and I think it's clear the IU takes the lead and should take the lead in the scientific definition by means of their own working group. For the rest, there is a need for everything else which needs to be taken care, and this is what this working group is going to try to do. So in conclusion, so as I said, a lot of mission going to the moon, you all know that, but at the moment there is no real way of coordinating between themselves except going straight to the United Nations. So the discussion has started. I have to say thanks to our persistent presentation of these topics in the course of the year, and this discussion has been initiated. So at the last, some of you have already heard, the last Science and Technical Subcommittee, the Romanian delegation happens to be the chairman of the GESLA, by chance, proposed the creation of a consultative mechanism on lunar activities, and basically following consultation, some of you were present in this consultation, it has proposed an action team on lunar activity consultation, and the goal is there is a lot of interest from the main delegation, but also from non-major stakeholder that there is this kind of coordination, and is going to go to the legal subcommittee in April for information, making sure that there is no objection and no, overlap with the Space Resources Working Group, which is taking place in the frame of the legal. I really hope that then we'll move quickly to the plenary of COPUOS when this action team will be basically finally confirmed. And you can see this action team, as some American colleagues call, as a landing team for a coordination mechanism, which is what is basically coming afterwards. So this, it's very important action, very concrete action by the side of the delegation, which realize the importance, and I hope that they will move forward in creating this, because this will be really an important, action. So the framework document as well is also related to the UN, Sustainable Development Goal, and we are participating also in the Summit of the Future, making sure that the moon and the coordination of activity related to the moon is included in the final text of the Summit of the Future. At the moment, the present draft does have that part, but we shall see how is the situation. So in conclusion, now is the time to start the definition of the site of specific scientific interest, including the moon Farside. I think let's leave the idea of the treaty to the provocation. Let's try to focus on something very concrete, which the member states could start to digest, and therefore it is very concrete action that we need to do. And with that, I'd like to thank you for your attention.
Do we have questions for the speaker?
Very clear.
Yeah.
What is the Summit of the Future?
Okay. Okay, yes. The question is, what is the Summit of the Future? Well, the Summit of the Future is the largest, let's say, event planned by the United Nations. It's a pact for the future generation. It is taking place in New York in September 2024. It has been preceded by at least 1 or 2 years of discussion. As far as the space segment is concerned, the Portuguese Space Agency has arranged for a number of meetings to prepare the definition of what goes inside the Summit of the Future document. And I am pleased to say that I participated together with a number of other organizations like IAA. Piero Benvenuti was there last week to basically make all these points to the largest audience. Space, as you can imagine, is a very small part in the largest problems, issues that humanity is facing, but it is also the future. It's the future for this generation, it's the future for humanity, and therefore it's important that it is mentioned and is given the right level of attention as well. Okay? Any other question? Because our speaker, okay? Okay, there's the question there.
Just provocative question, if you allow me. I'm from ITU. My name is Vadim Nozdrin. So actually, I noticed that one of the slides you indicate the word harmful interference. And I just want to ask you if you can refer me to any documents which says that COPUS should deal with harmful interference. So each international organization has their own mandate. So it means that it has to be some decision of United Nations saying that COPUS should deal with harmful interference. Do you have any idea if we have some treaty which says that COPUS has to be involved in harmful interference regulation?
Well, okay, first of all, thank you for the question. We have one of the experts of harmful interference between us, which is Ian Crawford, which is going to speak later. He is one of the next speakers. He has made a very nice definition of all of this, and it is definitely one of the very interesting discovery. This is interesting for everyone. In the treaty, when they are referring to harmful interference on the body, they are not referring to the environment. Harmful interference is purely refer of interference between different missions. So the environment right now does not have any place in the OST, just to be clear, okay? And this is one of the interesting, let's say, rediscovery maybe of this event, and that's why it's so important that the environment, it is now recognized and not is recognized as an obstacle vis-a-vis industry, but it is seen as an asset that can be used in a sustainable way. So I don't know, I hope I answer your question, but you will get more detail later.
Frankly speaking, I don't agree, but tomorrow I will give my vision of this situation. Okay,
okay, thank you.
Thank you.
Any other question? Okay.
Well then, thank you.
Sure, no problem.
Our next speaker is approaching, and he's Professor Martin Elvis, Center for Astrophysics, Harvard and Smithsonian's. And his talk will be about Farside sites for the ultimate dark ages cosmology interferometer array. Good. Let me share. There you go. This is forwards? Yeah, the big one is the pointer, back and forth.
Good, okay, thank you.
You're welcome.
Well, thank you very much for the opportunity to speak. I'm an astronomer and I'm not a lunar scientist, so this is a bit of an adventure for me getting into some lunar data with my student Zoe LeConte and Phil Glaser of Berlin. And Alana Krolakowski is my policy collaborator, and we've written lots of papers together, and she's, most policy things I say are all basically her words, not mine. Okay, so we've talked about the far side, but what do we mean by the far side? Where are we going to put these telescopes? And of course, right now it doesn't really matter. You can put it down almost anywhere because you're basically putting down one dipole and, or a few dipoles and seeing antennas and seeing what you can pick up. So, but it won't be like that forever, and we want to protect the far side, and this of course is what you all know. Starlink has alerted astronomers to the horrors that can come about by unrestrained, unregulated development. And this not only took us by surprise, it's having a big effect, and particularly on this billion-dollar class telescope that's about to go into operation in Chile. Now we know we shouldn't be caught out again, and we should look to the moon because that's the next clear case. So I think we all agree on that part of the situation. So what is this Dark Ages Cosmology Telescope? It's been mentioned already, but basically exploring at redshift 50 when the wavelength of the universe has expanded so much since that time that the wavelengths of light are now 50 times longer than they were when they were emitted. And that moves this one single line that atomic feature that we have to investigate the early universe into a range of the VHF channels. And so radio interference obviously matters. And that's why, of course, we go to the far side because of the 80 dB diminution of that signal by 1,000 kilometers of rock, basically, which is the moon. At first, we'll be dominated by, this is a map of the sky in about the right wavelength range, and you can see that this is in galactic coordinates. So the center of our galaxy is the middle cross there, and the plane of our galaxy is horizontal. And you can see that even away from the plane of our galaxy, there are some quite bright areas. And we've got to avoid, this is very strong signal. So we're going to have to look at the very darker regions. And the reason we're going to have to eventually have a telescope, and Joe Silk, if he's going to be talking later today, will explain in more detail. But basically, galaxies are assembled from small clouds with only 1 million times the mass of the sun. And those clouds give us far more information than counting galaxies, 1 million times more information. And so we will eventually want to extract all of that information. And as he points out, that means we need roughly 10 arcsecond resolution, and at these very low frequencies, to get that, your telescope has to be very large, about 200 kilometers across. So that's more problematic for where you might put a telescope on the moon of this kind. 200 kilometers diameter, those have to be fairly smooth regions. If you have to deploy these connected antennas, then you have to be able to travel over this whole region and to put down one after another of these antennas. And so it needs to be a fairly large and smooth area. And as you can see, looking at that picture of the far side of the moon, the topography of the far side of the moon, the far side is really mountainous. It's more restricted than just smooth. It has to have slopes that are less than about 15 degrees, which if you imagine that is really very small because rovers are very hard to design to go up steeper slopes than that. And really you need to have a smooth, a boulder-less terrain. If you keep coming across boulders that are bigger than your rover, then you can't traverse that terrain either. Even if the typical slope is 0, there's a boulder in the way every few yards, you can't move around that. And so here's a map of the slope of the far side, the antipode point, where it is the center of Claudio's region. And you can see anything. You can see the 200 kilometer size bar, and you can't draw anything around there that's purely blue or dark blue. All those orange and red areas are slopes that are too high for a rover to cross. So that's just putting it down at a random place on the moon is just not going to work. So we looked very simply by eye at a map of the moon and found 8 places where you might be able to put down a telescope of this size. They look kind of flat on these easy to look at topography maps, but that's not much detail. So Phil Glaser has derived topography maps for these zones, and Zoe LeConte, my former student, now at Durham University, has analyzed them for the smoothness and slopes. We're using the Lunar Reconnaissance Orbiter data. They have a laser that shines down onto the surface and reflects back, and you measure the time it takes, and that because we know the speed of light, so we know how far down it is. And it gives, in principle, elevations to within a meter, which is very impressive. It has a whole bunch of lasers. The satellite traverses the lunar terrain going from bottom to the top of this picture with this set of 5 LiDAR systems. But they don't always work all the time due to heating and cooling. It's a bit of an annoying problem. So you end up with a stripy map like this. I just want you to know that the data on which everything is based has problems. So we may have to do much better another version of this LiDAR to get the data we really want. But you can combine this with imaging data, and I believe there is a team in Copenhagen who know how to do this, and we hope to go to them next. Anyway, if you do interpolation, then you can make a very nice image. These are all images of Mare Moscoviense, which is a special place, as we'll see. And that's the perspective view of it, of the same map. But then, because of the falling out of some of the lasers, we don't really get 50-meter resolution. We get more like 200-meter resolution, and this is a slope map. Anything that's orange in this is not traversable. It's way above 15 degrees. And so you see there's a fairly large blue area in there that looks like you could traverse it. If you look at the roughness, this is basically the amount of bouldering that is in the way. Then you really can't go anywhere that's brown or yellow on this map. It's not going to be traversable readily. And still, there's quite large areas which are blue, and that's probably traversable. So these are the 8 different regions we looked at: the Apollo, Hertzsprung, Korolev, Mare Moscoviense, Mendeleev, Mare Ingenii, Tsiolkovsky, and Daedalus. And so we looked at all of those in the same way with the same kind of data I showed you for Mare Moscoviense. And the answer was there were just 3 of them that were good. These are too rough, those are too small, and so we're left with Mendeleev, Korolev, and Mare Moscoviense. And as you'll see, Moscoviense is our favorite. It certainly looks the smoothest on this image. But there's another thing to take into account that wasn't in that first paper, which I've just started doing, and that's to look at this map of the sky, of the emission and radio wavelengths from our galaxy in more detail, and say, where are you going to point your cosmology telescope to see this time before there were stars and galaxies? And the answer is, wherever it's darkest in this map. And so there's basically that region, and there's another one to the south. But if we just took that region, there isn't data for the southern cap yet, so maybe we'll find a bigger region in there. But let's take this one. It turns out that's in lunar type coordinates. It's a plus 75 degrees. So you can't have a southern hemisphere telescope and look at that spot in the sky. Maybe there's that counterpart in the south we could look at, and I haven't gone that far yet, so this is in progress. That can very much affect what's called UV coverage in an interferometer, which tells you how good an image you can make. And so basically you need to look at this space, you need to look at something as northern as you can. So let's look at the latitude of these different sites. Minus 36 is out, minus 20, plus 2, pretty bad, because now your region is only 17 degrees above the horizon, minus 6, plus 6, minus 34, minus 4, very unfortunate all this, plus 27 for Mare Moscoviense. So that becomes our favorite if we stick to that target location. And the point of this is not to identify really Mare Moscoviense particularly, it's that you've got to choose, you've got to flow down from you want to do this science, therefore you need to look at this part of the sky, and therefore these are the places you look at. If we later learn that there's a southern hemisphere dark spot, then that will change the calculus that I've just presented, but it's illustrative of the process that we need to go through. So interestingly, Mare Moscoviense is going to become news again for a different reason. Helium-3 has been completely ridiculed very effectively, I think, by Ian Crawford as a fusion power fuel. But apparently it is now very important in quantum computing because you can reach slightly lower temperatures than you can with helium-4. And I think everything goes exponentially in terms of coherence in the quantum computer and with the temperature. So a small temperature gain is a big gain in the ability to make that computer work. Helium-3 was thought to be uniformly distributed, but that was a very naive calculation. This Kim et al. Paper does a much more detailed job, not just using titanium dioxide as a proxy, but then also some other conditions that make it quite a sophisticated calculation, though not the ultimate, I'm sure. And basically, they find that there's regions on the moon that have several times, 3 or 4 times the density of helium-3 predicted anyway, than just a random spot on the moon, which is pretty bad. So it's still 20 parts per billion, so it's a very tiny amount, but those little yellow circles are the 8 spots I found on that map of theirs. And of course, one of them, MM in the top right, is Mare Moscoviense. Here's just an image of Mare Moscoviense with a 200-kilometer sized bar on it. And this is the overlay from that image by Kim et al. And you can see that that's where the hotspot is. So that will be one of the places they want to go mine, in particular because it's not on the near side. And they don't want to be, I imagine, accused of spoiling the view of the Earth, from the Earth, of the moon. So that's going to be an argument for going there. And just last week, Interloon came out of stealth mode. It's a startup with some serious people behind it. It's raised $18 million, which of course is a pittance compared with what they'll need to do this, but it's a sign of some interest from investors. And they will want to mine helium-3. So it's no longer, in principle, somebody might want to do it. There is an actual outfit who do want to do it. And one of my former students is actually involved in it. So I'm hoping to persuade her not to go to Mare Moscoviense, but we'll see. So we need to prepare. We've already mentioned in discussion about unintended electromagnetic emissions. This applies now in the shorter term and the long term. It applies to every time we want to make the measurements of these VHF wavelengths from the far side of the moon. We've talked about Che-Chao, which is the radio relay for Chang'e 4. Che-Chao 2 should be launching today, I believe, and be a much more powerful satellite. Has it launched? Great, I missed that. Thank you. It's today, yes? Oh, I was traveling, that's my excuse. Okay, and we've already mentioned these other constellations that are going to be flying. And so each of these, if you're going to do GPS from this, you need at least 3 satellites overhead at any one time. And if you want timing, I believe you need a 4th, is that right? So each of these constellations will always have 4 of their satellites overhead at any point on the moon at any time. And these are US and European, so there will clearly be a Chinese constellation as well, at least. So that will be a dozen satellites overhead at any one time, anywhere on the moon, including all of the far side. So we have to regulate, if we can regulate, down to 1/nth of the total signal we want. Each satellite must contribute no more than 1/nth, where that n is about 12, but perhaps more. And we talked about this. And of course, these designs, for at least for Moonlight, they're already talking with, ESA is already talking with contractors about the detailed specs. And so if we don't get in now, I mean, literally this year, we will have a real problem on our hands because they will not put in the necessary screening around their satellite electronics boxes unless it's a requirement. They just don't do it. So that's a real problem. Can we get in there? I don't know. Who has the right connections to ESA, for example? Okay, just quickly. Oh, we have volunteers in front row. Okay, great. I thought I'd re-mention with a little more detail what Lorena said earlier about other uses for the moon. Gravitational wave interferometers can do very well on the moon, covering frequencies that could not be done from Earth because of seismic noise. And this will open up, instead of a gravitational wave event being a flash, a sudden merging of the two black holes, you'll be able to see the two black holes orbiting each other and getting closer for several weeks. And that is a really big advantage for follow-up with optical light, for example. Far-infrared telescopes need to be very, very cold, and a great way to do that is to put them in a very, very cold place, rather than trying to have complicated shields as the James Webb Space Telescope does. And that would allow us cosmology measurements in the far-infrared, which should look for interesting deviations from a simple black body. Joe Silk, again, is probably going to mention that later and give you more reason. Both of these are very susceptible to dirt and vibration, and any kind of mining, and this is exactly the same photo that Lorena used, is dirty and lofts dust around, and it's noisy. So vibrations means seismic noise. Currently with the LIGO interferometer, if you drive a truck past, even some distance away, you clearly see it on the signal. So even a lunar rover some distance away is going to have similar effects. How can we minimize those? So hazards will abound for these new uses. And again, you can't put them anywhere. I've talked about these cold places, these cold traps. These are called permanently shadowed regions. They've been dark or have not seen direct sunlight at least for 4 billion years, and so they're really cold places. This is a gravitational wave proposed instrument. It needs 40-kilometer laser beam path in a triangle, and then it can do all these wonderful things with lower frequency gravitational waves. It needs to be cryogenic, meaning not many tens of degrees above absolute zero. And there are only 3 permanently shadowed regions that are large enough that you can put it inside, these 3 that are shown here in little circles. But this is a map of water content, purple being high water content. So Hayworth is out because it's going to be, and also Shoemaker, those 2 are good mining targets. So it could be that Faustini is the only good site which is dry yet cold. So that may be the only site for putting this particular gravitational wave interferometer down. Far-infrared telescopes have even stronger requirements. You really want to go, you can study all sorts of wonderful things with them, but you can need to get to temperatures that are more like 25 degrees absolute, or maybe 50, and to get the background radiation down from that the rocks are emitting to longer and longer wavelengths, so you can get out further and see more, and go to higher redshifts, for example, or the microwave background. So you need to go to the coldest of the cold traps, and if you stare at this map enough, you can see there's a temperature scale at the bottom, and at the very bottom end is some little purple patch, and if you look for purple patches here, there are those little spots here. They appear to be craters within craters, so ever so shielded. There are only a few of them, and they're only a few kilometers across, so again, like the Farside sites for a big array, we need to catalog them and map them and make sure which ones are the best to use. Eventually, we're going to want to build a telescope bigger than the European Extremely Large Telescope, which is 39 meters in diameter. The original idea was to build a 100-meter in diameter telescope called Overwhelmingly Large Telescope, or OWL. That had to be dropped because engineering analysis showed that sagging due to gravity as you move the telescope around was too much, and also that the wind would buffet it, and that would shake it too much to make it workable. But of course, none of this applies on the moon. The moon is no atmosphere and only 1/6 gravity. And so Jean-Pierre Maillard has pointed out there's a whole lot of things you don't need on the moon when you're building a big telescope, which can make life very promising for putting the next giant telescope on the moon rather than in free space. 1 more minute. Excellent. So here's my last slide. We've heard from Lorena. We're going to hear from Richard more about policy initiatives. I've been emphasizing in this talk the technical work that needs to be done. If you speak fluent NASA, you'll know that a science traceability matrix is essential. What is the thing you want to measure? What's the scientific question? What measurements do you need to make from that? What conditions does that impose on your environment? And then what pieces of the moon have the right conditions for that? And so it's a flow down from the basic science all the way to, this is the spot I want to protect. And we're going to need to have that to make our argument strong. So it applies to all three of these different types of detector, observatory. Thank you.
One question.
Ingrid?
In the back seats.
Oh, in the back seats?
Yeah.
I can't see that far.
Here in the front.
Okay.
Right at the back. Is that on? Yep, good. Charles Cranston, Project Manager for Lunar Pathfinder at SSTL. We're essentially doing the precursor to the Moonlight constellation for ESA. So happy to act as an engagement into ESA for Moonlight for you as well. Happy to have those conversations with you.
Splendid. This meeting has been very worthwhile already.
Excellent, good to hear. I can also assure you that with regards to how we're designing the relay satellite Pathfinder, we're adhering to all the ITU requirements. I'm giving a talk tomorrow that will highlight our adherence to the Shield of Solar Moon, including EMC requirements for onboard modules, so that we're not giving out spurious noises.
Great. Then the ball is back in our court. We need to decide to determine if those standards are tight enough for this very demanding measurement. So we can iterate on that then.
So we're working. Have you heard of Lucy Knight?
Yes.
Yes. So we'll be servicing that as our first customer. We're going up on the same launch as them, and we'll be getting their data back.
Excellent.
Cool, fantastic. Well, we'll catch up later.
Great news.
Cheers.
There was a question here in the front.
I appreciate the majority here are scientists, so you must forgive my ignorance because I'm only a lawyer. It could be useful at times to have rules, but my husband was a geologist, and therefore I'd like to ask you, couldn't mining or vibrations from mining on the moon set off some earthquakes or things? So don't we have that on the moon? Do we have any of these plaques that we have?
I believe it's quite possible that there are places on the sides of craters where you see there has been a small avalanche, basically. I would bet that in the wrong places that could again be set off, but I don't know of anyone who studied it. Probably a lunar person would know much more than me.
Before I invest all my money on the moon, will it have any effect on this Earth?
I'm sorry?
Will it have, before I invest all my money on the moon, will these possible dangers have any effect on the Earth?
No, I think we can rule that out. Yes, we can rule that out. It will not have any, yes. And by the way, I give talks in front of some very space enthusiasts who really love the idea of getting away from law and being out in the Wild West. And I tell them, you really don't want to live in a place which doesn't have lawyers.
Thank you.
Right. Richard Green, IAU. To get more of that microtopography, particularly in the shadowed regions, are there other data that are now accessible, or do we have to start bothering our space agencies for new missions?
Right. There are techniques like this Copenhagen team I would love to get back in touch with, who claim they can get 1 meter maps out of this data plus imaging data from the same satellite, LRO. So I'd do that first before even thinking about putting many millions into a new version of LRO. But it may be needed eventually, yes. Then there is if somebody will remember the name of the satellite that is imaging the interior of the so-called permanently shadowed regions, which are not completely dark because there'll be sunlight scattered from the far rim of this crater, and also starlight will be coming down onto them. And they've been successful in imaging a bunch of these permanently shadowed regions. I don't know, I can't remember the name of it. Somebody will, and, oh, Ian does, no? Thank you, ShadowCam. Yeah. And are they still operating?
Yes.
Okay, good. So that is going to be solved at some level by that. We will at least know the rough topography of them. Good. Oh, Ian.
Yeah, thanks, Martin. How much helium-3 does the quantum computing really need? I mean, is that really a big market?
Well, I think the answer is it isn't now, but if it works, then it'll take off in a dramatic way, and then the supply will be too limited. And the other question is just what is the cost of helium-3? It is very expensive now, but I've been told, but by my student who's working with Interloon, but working out the exact price, I haven't been able to do that. But it should be comparable to platinum or something like that, I suspect. More? Where are you? Ah, okay. Do you know the value per gram or? Per kilogram. Yeah, well, so platinum is $50 million a kilogram, so it's in the right ballpark, but more still. I mean, that's getting a kilogram out of something that's 25 parts per billion, that you can immediately work out the tons you need to mine through, and I won't refuse to try it while standing here, but I'll do it later. Okay.
So let's thank the speaker again.
Great.
Our next speaker is Professor Ian Crawford from School of Natural Sciences, Birkbeck College, University of London, and he will talk about astrobiology from the lunar far side.
Oh, thank you.
No, take your time.
Okay, I'll just take a sip of water.
Sure.
All right, good afternoon, everybody. Ian Crawford from Birkbeck College in the University of London. So I said I would talk about astrobiology from the moon. At first sight, this seems odd because astrobiology is the search for life in the universe, and as far as we know, there is not and cannot be any life on the moon. But actually, the moon has a lot to tell us about the habitability of the universe, I think. So that's what I mean by doing astrobiology from the moon. You see, this picture was taken by the Galileo spacecraft, and it shows the Earth and moon together. This is, of course, the far side of the moon. You can just see this slight cutout there where the shadow gets a bit bigger is the South Pole Aitken Basin. The main reason why the moon is useful for astrobiology is because it spent 4.5 billion years orbiting the only known inhabited planet in the universe, and therefore lunar geology preserves a record of the space environment of the Earth throughout the whole of the Earth's history, and much of that is of relevance to the habitability of the Earth. Although we'll see in a minute, much of the lunar geological record that's relevant to astrobiology doesn't specifically have to be on the far side, which is what this conference has to be about. But I'll come to that. There are a few things that are relevant to the far side, and Martin has alluded to them. Other speakers have alluded to them. Certainly all the low-frequency radio astronomy, much of which will be astrobiologically relevant. Yes, that will have to be on the far side because to be shielded from radio interference from the Earth. So I'm afraid I've got this very long list of astrobiology from the moon, and just bear in mind, astrobiology is only one of the sciences that will benefit from exploring the moon. I could give another equally long list of geological and planetary science reasons for exploring the moon, but this is my list of astrobiology benefits. They start from what is quite prosaic, like the impact cratering record on the moon, because the moon's been orbiting the Earth all this time, the impact cratering rate on the moon is more or less the impact cratering rate on the Earth, and has been throughout the 4.5 billion years of Earth history. So pinning down the lunar cratering chronology also pins down the Earth's cratering chronology, and that has some impact on the past habitability of the Earth. A record of solar and galactic activity relevant to Earth's habitability. This picture you will recognize, I hope, it's Jack Schmitt from Apollo 17. The point here is that this is the lunar regolith that Schmitt is walking over here. Because the moon has no atmosphere, and because for most of its history at least the moon has had no strong magnetic field, the lunar regolith is totally exposed to the cosmic radiation environment. So solar wind particles and galactic cosmic rays impinge on the lunar regolith unimpeded. So there's a record here on the moon of the past activity of the sun, inferred from the past cosmic solar wind fluxes, and past galactic environment of the solar system inferred from the cosmic ray fluxes. So every time the solar system has been close to supernova explosions, which it probably has been at times in the past, you'd expect an enhancement in the cosmic ray flux. These are going to be preserved in the lunar regolith. That's also relevant for understanding the past habitability of the Earth. Preservation of cometary volatiles and organics in permanently shadowed craters. I'll come to that in a bit. Possible meteorites containing biosignatures from the early Earth. I'll come to that in a bit also. There are other exotic possibilities. We have a talk on technosignatures later. And of course, the technosignature that is most discussed is radio SETI observations, and this will need to be done from the far side, which Claudio has advocated for a long time. But there are other possible technosignatures, though. The more technological civilizations that have existed in the history of the galaxy, the more space junk they will have produced. Some of this space junk might be very small, micron-sized particles, and some of this may have found its way into the solar system, and the place to look for it, if anywhere, would probably be on the airless surface of the moon. There's astrobiological interest in understanding the survivability of microbes and organic molecules on the lunar surface. And all of these, up to the last 2 bullet points, these are all astrobiologically relevant studies which can be done on the moon. And then we have the 2 relevant astrobiological studies that can be done from the moon, because these are observational astronomy. So Martin mentioned the possibility of large infrared and optical interferometers on the moon, so they'll be very useful for studying the atmospheres of exoplanets, where you need a very high spatial resolution, so you need a very large telescope. And then there are the radio observations from the far side, of which the astrobiologically most important examples, I think, are the study of exoplanet magnetospheres and the search for alien radio signatures. So I just want to say something about the polar regions. I know this meeting is on preserving the far side, but the moon also has other environments that need to be preserved, and Giuseppe alluded to them, of which the most important, arguably, are the lunar poles. So here, this is the south pole of the moon, taken by Japan's Kaguya spacecraft. This is the Earth, obviously. This is the south polar crater Shackleton. And here we have a lot of shadow. We have a lot of shadow because the sun is always on the horizon at the lunar poles. And so there's now pretty conclusive evidence that some of these craters at least contain water ice. And that water will have come to the moon, some of it anyway, from comets and asteroids from the outer solar system. And so there's a record in these polar craters of volatiles and associated organics, which have been delivered to the moon through time. But because the moon's been orbiting the Earth all this time, what we find is a record of organics delivered to the lunar poles will also be a record of organics delivered to the Earth. So this is also of astrobiological relevance. And it's quite important that we don't overly contaminate this record before we have a chance to study it. So I'm going to make a special plea here that in addition to the far side, the lunar polar environment is also a region that's deserving of special protection for scientific reasons. I won't say more about that now, except myself and colleagues wrote this article in the COSPAR journal, Space Research Today, a couple of years ago, making this case. Here is a picture of Buzz Aldrin's boot. and it gives you a good example of what the lunar regolith looks like. So this is, I've written astrobiological treasures in the regolith. This is the surface in which solar wind particles and galactic cosmic rays have been implanted through time. It's also the surface on which we might find meteorites derived from the early Earth, which will also be of astrobiological relevance. I mean, here is a rock in front of Aldrin's Boot, and obviously this is will be a moon rock. But there will be places on the moon where rocks will be meteorites that have been blasted off the early Earth, made their way to the moon, and yet they may date from this time on the Earth's history, the first 500 million years or so of Earth history, for which the Earth itself has lost its geological record. So perversely, the moon may be the best place to find fragments of the Earth's earliest crust, and with it a geological record of what the Earth's environment was like at the time life appeared on our own planet. So all of these are astrobiological, possibly astrobiologically relevant aspects of the lunar record. And here I've just got the extraterrestrial artifacts, technosignatures again, but perhaps I won't say any more about that unless anyone wants to ask me during the coffee break. But this was an idea proposed. The person who first proposed this, to my knowledge, was a Ukrainian astronomer, Alexei Arkhipov, who was publishing this idea that the moon might be collecting microscopic-sized space junk from alien civilizations. Have there been any in the history of the galaxy? And we may laugh at that, but you can't laugh at that on the one hand, and at the other argue that we should be preserving the far side of the moon for SETI. Either these extraterrestrial civilizations exist or they do not. If they don't, there's no point in building SETI telescopes on the far side, and there'd be no point in searching for alien artifacts on the moon. On the other hand, if they do exist, there's an argument for both, searching for both types of technosignatures. So I've already said more about that than I plan to. Radio astronomy from the far side. So nobody's shown this diagram yet. So this shows the opacity of the Earth's atmosphere as a function of wavelength, and where it says 100%, nothing gets through from outside. So this is why all gamma ray and X-ray and UV astronomy has to be in space. Then we've got the windows, the optical windows, some infrared windows. Then it becomes opaque again in the far infrared. This is why James Webb is doing what it's doing at Sun-Earth L2 point. And then radio waves get to the ground, of course, but not if they've got wavelengths longer than about 20 meters, because then the Earth's ionosphere becomes opaque. So this is why the radio astronomers, for the most part, are advocating radio telescopes on the far side of the moon, both because it's radio quiet, because it's shielded from the Earth, but also because it's in space. If you want somewhere in space that is above the Earth's ionosphere and is also radio quiet, then the far side of the moon is it. It's the only place in the solar system where you can really do that. So I'm here to talk about astrobiology, but I just want to make the point that the astrobiological applications for radio astronomy from the far side of the moon are, of course, only a subset of all the other astronomical reasons for going to the moon. I draw your attention to these two conference proceedings. These are conference proceedings from a meeting we had about a year ago at the Royal Society in London on astronomy from the moon, and we've got two conference proceedings out of this meeting. The first one has already been published, and the second volume of Astronomy from the Moon gets published on next week. And these outline a whole range of different reasons for wanting to do astronomy from the moon. But of which far-side radio astronomy is only one. Still, far-side radio astronomy as applied to astrobiology, which is what I said I would talk about, I think it boils down to these 2 bullet points. Studying space weather and the magnetospheres in exoplanetary systems to assess their habitability and radio SETI, as discussed. So I'm indebted here to a paper by Jack Burns, and Burns has an excellent article on that in the first of these Royal Society proceedings. I think the key thing here is the most common types of star in the galaxy are the M-dwarf stars. And we now know that low-mass planets are extremely common around M-dwarf stars. But there is a known fundamental problem for the habitability of planets orbiting red dwarf stars, and that is because the habitable zone is so close to the star, and because red dwarfs are so active, with many flares and coronal mass ejection events. The radiation environment close to a red dwarf star is probably not very amenable to habitability. So it would be important if these planets have magnetic fields. Because like the Earth's magnetic field protects us from the solar wind, exoplanets orbiting red dwarf stars would be protected from coronal mass ejections and flare activity on their host stars. So in principle, we could observe this because coronal mass ejection events emit low frequency radio bursts, and magnetospheres emit cyclotron emission as electrons spiral around magnetic fields. But many of these are at very low frequencies. And the far side of the moon is probably, so I've taken this from Burns's paper, frequencies less than 10 megahertz. So that's wavelengths greater than 30 meters. These are wavelengths that cannot be observed from the surface of the Earth because of the Earth's ionosphere. So if we wish to study radio emission from planetary magnetospheres around nearby stars to help assess whether they're likely to be protected by a magnetic field or not, low-frequency radio astronomy is the only tool we're going to have, and the far side of the moon is the only place to put it. And I think if I was to strictly identify just the lunar far side applications of radio astronomy, which is what this meeting is about, this would probably be the strongest. I put a flag out for Burns's paper and concept that he's been working on for many years, the Farside, it's called Farside for obvious reasons, Farside concept, which would deploy 120 antennae in this petal shape with a diameter of about 10 kilometers, and it would have to be, so it's not as big as some of the deployments that Martin was talking about with a 200 kilometer baseline, but still of the order of a 10 kilometer diameter array of radio antennas to study low frequency radio emission from the magnetospheres of nearby red dwarf stars, of which there are about 2,000 within 25 parsecs, and I think 25 parsecs they took as their limit for this instrument. Anyway, it would be a rover deployed instrument, and the rover would deploy a rover, deploy the antennae, but it would require a radio quiet far side. So this is the argument for having a quiet far side from astrobiology purposes. And then there's SETI. So this is the JPL concept for the Lunar Crater Radio Telescope. I don't actually know whether Farside SETI requires a parabolic dish like this. I just like this design because obviously it resonates with the lamented Arecibo telescope that did so much, involved in so much SETI work. But in any case, the reasons for wanting to do SETI on the far side of the moon are slightly different. You don't necessarily have to be working at very low frequencies, because we don't know what frequencies the aliens will be transmitting on. But you do have to be in a radio quiet location. You do have to be shielded from radio interference from the Earth. And again, the far side of the moon is the only such place in the inner solar system which is sufficiently shielded from the Earth. But then, of course, since we don't know what frequencies the aliens are transmitting on, for all we know, they might be transmitting at very long wavelengths. So there's also a case for extending the SETI searches out to wavelengths that are longer than what the Earth's ionosphere can transmit. Oh, and here's one of Claudio's papers. I mean, Claudio has really been advocating this for many years. But there's a more recent paper, this is a white paper for the last Planetary Science and Astrobiology Decadal Survey, Michaud et al. On lunar opportunities for SETI. So there's a reference, should anyone be interested. So that's all I want to say about astrobiology from the moon, except Giuseppe told me I had to talk about the Gegsler working group. I've only got this one slide. So as Giuseppe said, yes, the Gegsler has a working group on lunar environmental protection. It's co-chaired by Jean-Claude Worms from COSPAR and myself. So if anybody is interested in contributing ideas to protection of the far side of the moon for scientific purposes, then please do get in touch. Right, thanks, Nicola. I think I've finished. Any question? So I'm amazed there are no questions about the alien artifacts, but maybe Richard's going to.
Richard Green from IAU. I'll disappoint you. I wanted to go a different direction. Can you tell us some more about the concept for the North Polar Reserve and why that would be a good place for studying the kind of in-ground artifacts that you talked about?
Well, thank you, Richard. Well, I'm happy to talk about the North Pole of the Moon, although it's mostly relevant for the preservation of polar ices. But it does, thank you, because it does give me an opportunity to expand on this. I'll try not to shoot Nicola with the laser beam. Oh, what have I done now? Oh, there we go. No, it's all right. Obviously, the poles of the moon are special places in large part because there are these areas of permanent shadow, which are very cold, like 40 Kelvin or less, where we believe ice will accumulate, and along with the ice, other volatile and organic materials that are of great interest. The moon has 2 poles, and for better or worse, all current planned activity, to my knowledge, is predicated on doing things at the South Pole. So this is the Shackleton crater. There's a lot of effort going on the rim of Shackleton. This is de Gerlach. This is the de Gerlach-Shackleton Ridge. Anyway, there are a lot of sites in this area of the moon which are soon going to become very busy and possibly quite contentious, which is why international agreements are going to be important. But nobody is yet planning on building hardware to land on the North Pole of the moon, which also preserves the volatiles just as well as the South Pole. So I do think there's a case, it's a case we made in this article, for placing a moratorium on future activities at the North Pole of the moon until we assess just what impact we're having at the South Pole of the moon. I mean, we are going to have a lot of impact at the South Pole of the moon. It may be very bad, it may not be so bad. It may not do any harm at all to the lunar environment, because currently we don't really know. But over the next 20 or 30 years, we will build up a lot of experience operating at the South Pole of the moon, and we will be able to tell whether contaminants from rocket exhausts or dust generated by rocket landings gets into permanently shadowed craters and contaminates the scientific record. So the idea is that if we were to place a moratorium on activities at the North Pole of the moon, while we're learning all of this at the South, we've at least got one pole of the moon in reserve in case we really do make a mess of the South Pole of the moon. So that was the argument, Richard. I don't know, does that answer your question? I should say all the other things I talked about, like the solar wind, the galactic cosmic rays, the terrestrial meteorites, and even the alien artifacts don't need to be in permanently shadowed craters. They don't even need to be on the far side. So most of these studies could be done anywhere on the moon, so they're much less sensitive to environmental degradation from human activities.
Thank you. Well, thank you very much for the last point. Actually, you know that my dream is finally to arrive at a treaty and so on. So we should put this that you just said in the draft treaty, because this gives us a possibility to save at least one pole.
I think we may need, I'm going to say more than a treaty, or in a sense we have a treaty. I mean, in a sense the Moon Agreement already has, I think it's Article 6 or 7. It's just that we can't get enough member states to sign up to it. In any case, whether it's done through a treaty or through some other coordination mechanism, I think the poles of the moon also deserve special protection for scientific applications in addition to the radio quiet zone. So I agree with you. I'm not sure whether that's a question for the space lawyers, whether a treaty is the most appropriate instrument.
Well, it's a matter of more words playing than reality, probably. Thank you.
Thank you,
Okay.
Professor Crawford.
Okay, thank you.
Okay, we'll have a break now, and we'll be back here by 4:30. Okay, by 4:30 we'll be back here.